Hey everybody, we're back. Welcome to CMP Sunday show. Once again, I'm here with Daniel as usual. Daniel, say hi to everybody.
Hello.
Yep. And let's get to a little bit of news. What's going on with the channel and what I need to put out here. One, we're going to be starting a Facebook channel. So that means you'll be able to watch us. Well, we'll have a link up for Facebook, and then you guys can go from Facebook over to here. We're going to open up a channel so you guys can chat with everyone and have conversations and all that. I'm also looking at getting a Discord service set up, maybe. Maybe. Just saying maybe because I know there's a lot of Discorders out there that we all can jump on, but I'm wondering, would you guys want that? Also, we are going to launch the Patreon. What the Patreon's going to do is going to help support me and support Daniel here, who does help with every so often. And what we may do is post like little tips and tricks just for Patreons only, so those videos would never see the light of day on YouTube. And I will post it over to you guys. I will also have first shot interviews. So if we're interviewing somebody that I think you guys would find interesting, you guys will get the first view of it on the Patreon, and then a week later it gets pushed out to YouTube. I'm also going to try to put these out as podcasts so you guys can listen to them not tethered to your computer. You know, say you got a cell phone that allows you to stream your audio, you can do that too. But there's a lot of things that are changing on the channel. Still a lot of conversations we're still having. We're still ironing out everything because, well, number one, I'm tech head, but I'm not a web page tech head. Let's just put it that way. But as always, I brought Daniel on the show. So Daniel, introduce yourself again for the people who don't know who you are, and to the new people that are here, thanks for coming on.
Sure. Well, hi guys. My name is Daniel Halverson. I'm a maker, 3D printer enthusiast from Minnesota, Mankato, Minnesota, South Minnesota. Been printing for about 4 years, a little over 4 years, and I love building machines. I love designing machines. I love the kinematics. I love the motion systems. I love the material science. I love it all. Oh, gosh. I just seriously nerd out about this stuff, and it's so much fun for me to be able to hang with people who, share that passion too. Ron here is a buddy of mine. Met him online. What was it? In one of the Facebook groups, right?
No, we met in that. It was first Murph, and
Or
then again in Earth.
Was it Earth or Murph? I mean, was Murph the first time we met?
Yeah, Murph was the first time we met because you were
Oh, right.
behind the desk working and selling the filament.
Yeah.
I think you left early, did you? Or no, you were driving. We went out for wings at the end of the night.
Yeah, yeah.
Yeah.
Yep,
Okay.
yep, yep. Right, right. I mean, I meet a lot of friends online. You know how 3D printing is. There aren't quite enough people to have like physical friends, right?
In one area, yeah.
Meet space, that's what I call it, in one area. But it's neat to have the internet because we can hang out with our friends virtually and chat, have conversations like this, hang out with you guys, even though we're quite a long distance away.
Yeah, that's the bad thing about it. But hey, at least we have the internet.
That's right. That's right.
Oh, what was that line from that one movie? We would always have something. There's always Paris, was it? New York? I can't remember
I don't
now.
remember.
And this is just going into the dive of the old stuff. So let's get some other work done. So we got John Mack in the house, Willie 3D, Apocalypse Survivor, Minnesota Maker, one of your favorite fans. We got the 3D printing kid. Thanks for coming in, man. We got Nat 3D Design. And we got PT 3D in the house, too. So thanks for everyone for coming on, and we appreciate it. And hopefully we'll have some great conversations. So getting on with news. Has anybody played with... Have you read the reviews of the CRX?
The CR10X, so that's the dual extruder, right, with the independent.
Yeah, it has
Yeah,
like two extruders going into it.
Okay. Oh.
The Nucleality
Two
printer.
extruders. Okay. No. Honestly, I haven't How
Okay,
about
well, Joel
does
came
it
out
read
with
stuff?
a review, and it was pretty bad.
Really?
Oh, he hated the printer.
Okay.
Here's some of the things that Joel talked about, which I really think he hit the nail on the head. One, all the files were in a separate folder, so you had to put them all in the root for you to be able to print them off, print the G code off.
Oh, weird.
So you had to go find them. Now, Angus reported that they were in Chinese. When you put the SD card in there, it was not able to read the Chinese code.
The heck?
Yeah, the titles
Okay,
were in Chinese.
that's not workable. I can't work with that. What?
The printer comes default with Chinese built in on it.
Please tell me that's like a prototype or a mistake or something. Like what?
We don't know. The prints come out okay. Not great, not amazing, just meh.
Just meh. Yeah, yeah. Good comment there.
And what was the other? Oh yeah, you have to have both filaments loaded because if you don't put both filaments in and you only print one color, it'll go out the other end.
Yeah.
The other extruder
Yeah.
will pull it through. So it doesn't go directly into the head. It goes out and over and then out the other end.
Weird.
Yeah.
Hope they get those issues fixed.
Yeah, and I mean, the printer being alone in Chinese is really annoying because you have to figure out how to get into it to change it to English. Joel got it on hit, but I think it was I think Angus was having a little bit of a problem trying to figure out where the heck it's the link. Oh, there it is. Okay, there.
I like
And
PT3's or PT3D's
yeah,
comment here that. Hang on, I'm having trouble reading the chat. I gotta.
I think it's the beta that rolled out.
Zoom. There, yeah, beta rollout. And Apocalypse Survivor, nice comment. Hey, if you're really serious about 3D printing, you know you have to learn Mandarin. Hey, have you guys seen Angus's video recently about the problems that well, it's really interesting in the hardware industry here. It's been common in the software industry for a while to do something called agile development, which is where you're constantly rolling out updates to customers. You know, you can
Oh
ship
yeah.
them a product that's kind of unfinished, but then as they give you their feedback, you know, you roll that into the next version of the product and they get that update for free. Well, unfortunately, that mindset has kind of transferred over to 3D printer development, and Angus went off on that like so hard.
Oh, he did.
Makerspace has a
I
good video.
watched him.
You watched that one? Yeah.
I
Oh,
saw the
I
live.
enjoyed that
I saw
video.
him doing the live build, and they said, "What are we effing beta testers?"
Yeah, exactly. Like, you know, people
Like he
don't
just blew
pay
up.
to buy this. You know, they pay to get the finished printer, you know.
Yeah, he's like, "Wait, what just happened here?" Like when he got that printer, he looked at it. He's like, "There's no CQ. What are we, the CQ people now?" And
Right.
he like blew up on live video. It was interesting listening to him because he was being very truthful, and I agree with him. I feel that sometimes when we get these printers, we're beta testers. I
Yeah.
mean, I opened up one printer for a friend just a couple days ago. I forget what model it was, but after we put it together, nothing was working. I spent 3 hours doing freaking testing and finding out it's bad power supply. Even though it turned on, it worked. It was only getting 11 volts, and you needed a full 12 volts to make this printer work properly. It was like,
Uh,
what the?
yeah.
Oh, never mind. I can't go
Yeah,
on
I
anymore.
absolutely agree. NAK3D, it's totally awesome for software and firmware. You know, I don't have a problem with that at all. But for hardware, yeah, it's the mindset doesn't apply. You know, you're not, as a hardware company, you're not going to want to freely like go out and just continually give revisions of hardware to all your, you know, previous buyers. That's super expensive. Like, It's just silly, you know. People don't want to do that. Um, it's so much better to just design the thing properly, test it fully, and ship it done. You know. Uh,
Yeah, it's just bizarre. So what I wanted to talk to you a little bit more that we should actually dive into is what is like when you're looking at buying NEMA 17 mortars. Let's just say you're buying whatever brand it is. How do you know you're getting a good mortar? Like, what should you be looking for when you're making that purchase?
um, oh, it's a good question. Um,
'Cause I know right now you're in the process of working on your new printer that you've told me about, so which we can't
right.
explain it right now, but
Yeah. Well, there are a couple things I look for. Nowadays, um, stepper motors, like, you know, in the commercial sizes, like NEMA 17 type stuff, is just so standardized. You know, it's such a common feature in so many types of machines. You know, um, that it's like a commodity item. You know, it's traded in bulk. You know, these companies make NEMA 17 motors, and they have such a phenomenally high um, functioning rate. You know, there are very few duds nowadays. Um, you know, for all intents and purposes, a stepper motor is a stepper motor on a basic level. I there are some bells and whistles that money will buy you, but a 1.8 degree NEMA 17 with, you know, a certain rated current, rated voltage, rated impedance, rated resistance, and rated torque, holding torque, will basically be the same whether you buy it from a Chinese company or an American company. It's very, very similar. Um, that said, so all these stepper motors are, you know, basically the same. Yes, trolling for dollars is correct. NEMA number, uh, you put a decimal point between the two numbers. If it's like NEMA 11, that means 1.1 inches across, roughly. NEMA 17 means 1.7 inches across, roughly. It's actually kind of a metric thing. But from that point on, all the specs, as far as like the motor constants and things, are totally variable. So um, you can get NEMA 17s with wildly varying properties. For example, you can find NEMA 17s in several different step angles. You can find some in 0.9 degree, 1.8 degree. You can even find some in 0.45 degree, which is, what is that, 800 steps per revolution, which is crazy. That's nuts. You can find them in pancake sizes with torque down to like um, a tenth of what you can find on the larger, like triple stack NEMA 17 motors. Um, so the rated specs are definitely important to be looking at when you're buying a motor. But the only one that I really pay attention to when I'm buying a NEMA 17 is the rated holding torque. That's the single spec that has the most um, impact on a 3D printer. And of course, the step angle. You know, if you're using like a 0.9 degree versus a 1.8 degree, there is a noticeable difference there. But the holding torque is basically the main thing you look at. A 1.8 degree, you know, standard with like a, say, 3.6, you know, Newton meter or Newton centimeter holding torque is like kind of a standard-ish size, somewhere in that ballpark, like plus or minus 20%. All those motors are basically functionally the same.
okay. And I noticed the Apocalypse Survivor put out a question for you. It says, "What are some of the examples of the one would want to choose a .09 mortar to use in a movement system?"
Good question. So, um, if you're running um, a more high performance printer, say um, you're running tighter tolerances. All the rest of the motion components are good and tight. You've got solid rods, you've got in general just components that are well made, well spec'd, well assembled, well squared. Then yeah, in a lot of Cartesian builds you might start to see an improvement in the motion quality when you use 0.9 degree motors. However, one thing I would note is that one motor that's made in 0.9 degree versus an equivalent height motor that's 1.8, you will typically see the 1.8 degree stepper motor having a bit more torque, just because of the way the magnetics work inside the rotor. So as a result, the 0.9 degree steppers do tend to be a bit larger to get the same torque, and often you'll want to run them on like a 32-bit board, just so the step rates are nice and high. You could like decrease the micro step. You could have the micro stepping on a driver and then swap in a 0.9 degree stepper instead of a 1.8, which will keep your theoretical resolution the same, but will make the motion smoother. That's one option. Although, so even though there isn't a whole lot of difference between the two, like functionally, both will get the job done. It's just that 0.9 degree steppers will give you maybe a little bit of edge. However, there is one space that I think it is actually pretty beneficial to have a 0.9 degree stepper, and that is if you are running a direct drive extruder. And by direct, I mean like no gearing. If you're running an extruder that has just your motor, drive shaft, drive gear, you actually do tend to see a bit of improvement, noticeable improvement with a 0.9 degree stepper. Now keep in mind, you got to have enough torque to get the job done, so that's still a factor. But the thing that a 0.9 degree stepper will net you is the increased resolution, which is handy if you are pushing very, very small amounts of filament. So if you're printing at low layer heights, say like 80 micron, 50 micron, 40 micron, whatever,
Okay.
a typical like 1.8 degree stepper is going to have a little bit of difficulty dispensing just the right amount of filament, because, as we all know, microstepping is not exactly like perfectly sinusoidal, and the way that it indexes the motor isn't totally smooth. All right, see you later, Country 3D.
Yeah, like country.
Yeah. So a 0.9 degree stepper will have the distance between pulses of the extruder and just give you a little bit cleaner output. Personally, I would recommend like a geared extruder, like a Bondtech BMG. I am a super big fan of a Bondtech BMG. I would recommend that over like just swapping in a 0.9 degree stepper. But in some cases, it might be handy. For instance, in that silent delta that I've been building that I talk about sometimes, I wanted to make sure that the extruder made no noise. So what that means is no clacking gears. Another issue is like I want to reduce the number of bearings in it so that little sound is less. So I didn't want to have like a belted extruder either. So because that Nozzle does a lot of smaller projects, I have it chucked up with a 0.35 millimeter nozzle instead of 0.4. It tends to print things on the smaller side, a little more precise. I print a lot of things at like 50 micron layers. It really does help to have just a straight, plain old, motor, shaft, drive gear. Because that way you get, few moving parts, totally silent, and with the 0.9 degree stepper, it does give me the resolution I need. So.
Okay. Well, going into, with using just drive gear, Now, would you say the couplers, the new ones are better, or did you like the old ones, which were just all as one?
What do you mean by couplers?
Oh, okay. Let me grab my printer here. Give me a moment. Yes, again, we're pulling out the old Troxy to use it as an example. It's the
All
only one
right.
I have that's portable, really. Okay, so looking at this coupler right here, I'm talking about that
Oh
regular
yeah, yeah,
coupler,
yeah.
or do you like the ones that come apart now, the new
Okay,
style that's
so
coming out?
yeah, so um, this is. I have a lot of fun with this sort of thing. Um, I just noticed that fly swatter was hanging up behind me. It looked kind of funny. um, so yeah, couplings or couplers are a very interesting section of machine design, and they don't make a lot of sense unless you study constraint theory. What a coupler is fundamentally designed to do is to link two shafts, and in our case, that's a motor and a lead screw, rotationally, so that they're exactly synced, no backlash, while allowing for XY translational misalignment to some extent, and also angular misalignment, right? You know, in case they're pointing slightly different directions, you want it to be able to take that up. Now, a helical coupler is actually pretty good at those things. However, yeah, they can be kind of bouncy if you don't have the two shafts meeting, and if you do have the shafts meeting, they can tend to like bounce, like slip from side to side as things circulate. So I tend not to recommend helical couplers, which is the old style. Now the new style, I mean, you know, for CNC machines, this is all old hat. They've been using these products for forever. But the new style of, they call them either plumb couplers or spider couplers. The spider word comes from that red rubber thing in the middle, which connects two halves, right?
Yeah.
Or they sometimes call them plum couplers because originally, like back in the old days, they were kind of plum colored. Um,
Yeah, now they're like an
that
orangey weird color.
Yeah, now it's kind of a reddish. Yeah, um, I like that style, and I like it
Okay.
a lot because it does a really good job at linking them, but allowing them to flex a little bit in the ways that you want, about the amount that you want, with no backlash, but smoothly. So
So
I like those.
yeah, when I look at them, I think of a gear. So you know how a gear would lock into this, lock into that way, and would turn and be able to turn this gear.
Hmm.
That's what I look at them as that way, because
Sure.
you can actually adjust them to whatever you need it to be. So if you had it on an angle, it'd still
Yep.
lock in and still be able to turn
They
it.
they still fit. You know, even if your motor is maybe mounted kind of cockeyed, it'll still be able to turn the lead screw correctly.
Yeah.
Yeah. Yeah.
Well, okay, getting out of that then. No, we probably drove everybody crazy.
Yeah.
If you guys have any questions, you know, you're free to ask away. We do have a link where we can bring you in if we feel that your question is valid enough and you can be part of the conversation. We have no problem inviting others into the channel. So if you're out there and got a question and you think it might be valid, you know, post it up here and we'll be more than happy enough to bring you into the chat and conversation.
That's right.
And Daniel loves talking to other makers, so don't be scared to ask. Here's a good question. What about integrated lead screws? What's your thoughts on those?
Hey, that's a great question. So, um, in a theoretical world, right, where all of the parts are separate, right? You know, you've got each part doing only one function. A motor is just a motor, and a lead screw is just a lead screw, and a nut is just a nut, and a coupler is just a coupler. Um, and everything is perfectly straight, and everything is perfectly aligned. Okay, um, that would be ideal, right? Um, you know, there'd be no print issues whatsoever. You know, everything would work perfectly all the time. Well, that's obviously not reality.
I don't think that world ever exists.
Yeah, yeah. In theory, right? You know, in theory, that's the land we call it, theory. I would love to go live in theory, but the problem about the place called theory is There's also no air resistance because there's no air and there's no friction. It's a frictionless surface. Physicists would love to live there.
Oh man, that would be a weird world.
That would be a weird world.
They'll be all
Anyway,
dead too. But
yes, they'll be dead. The fact is, we're not there. In real life, shafts are misaligned. Stuff like that happens. So
stuff takes forever because it comes from a slow boat from China.
that's right, and sometimes shafts are bent. So now the question is it better to have, say, a bent shaft on a coupler, on a normal lead screw nut, or is it better to have a motor with a hollow 8mm core and have a lead screw pressed into it? Which is better? Well, I would say this: if the lead screw is bent or significantly bent, a lead screw integrated motor would not be ideal.
No, I wouldn't think that either.
Right, because as it holds the lead screw pretty tightly down there, and the lead screw end would be whipping around.
Exactly.
However,
and depending on the angle it's at, that could also cause bending with your z-axis as it's going down. You could actually damage your the whole gantry itself if it was running on the gantry or running as a core XY.
possibly, yeah. And what you would probably notice is a noticeable amount of z-wobble.
Yeah,
From that.
definitely.
You would definitely notice, especially like at the top.
Well, depending
However,
where the pull would be, I mean,
yeah,
that would really make the difference because it may not even go all the way to the top either. It might
that's true.
bind up and then it'll be useless.
Right. So, however, in real life, this is a funny thing, because a lead screw is just a cheap commodity, and they often package them cheaply, they're more likely to ship to you bent than a lead screw motor. Now, a lead screw motor is usually a more expensive item, and they tend to ship those in like hot wire cut foam packages, and like they've got a cardboard sleeve, and those usually arrive very, very, very straight, which is actually pretty nice. So yeah, while if you had a bent lead screw, a shaft coupler would kind of be a necessity. In real life, an integrated lead screw is a kind of a practical way to do it, because usually you can count on those being basically straight, which you can't so much with the El Cheapo, Chinesium straight lead screws.
Now, here's where we get into a little bit of fun conversation. I'm going to play devil's advocate here. Okay, so I have the lead screw in the mortar. Okay, what happens if that mortar was to die? Are you?
Yeah.
Is that your end?
Well, I don't know. I've never really had a motor die per se. What's inside is all usually pretty solid packed in resin, and not a whole lot to go wrong in there, unless it overheats or something. That can happen if it gets too hot and say it loses its, maybe it passes its Curie point or something weird, and the rotor loses its magnetism, and it could happen, right?
Yeah.
You would have to get like a hydraulic press and press out that lead screw, and you could salvage that. The motor would be toast, but you could do that.
Okay.
However,
So
that brings me to another point. Sorry, didn't mean to steamroll.
Yeah, no, I heard that bell sound. I wasn't too sure where that was coming from.
Yeah, this is another interesting thing then. Lead screw integrated motors, or properly I should say, a pre-chosen lead screw pressed into a hollow shaft, stepper motor, they tend to not give you that many options about what type of lead screw you use. Generally, they're all just TR8x8, force start lead screw, 8mm diameter, Acme, trapezoidal thread, 2mm pitch, force start. Yeah, that's like all of them I've seen. It's really hard to find one with my preferred lead screw of choice, which is a single start Acme TR8x2. So the only way I've been able to do that so far is the traditional method of having a normal stepper and a shaft coupler and then stick that lead screw in. So that's one tick in favor of that way, the traditional way, not integrated lead screw steppers. You can choose your lead screw and you can swap it out if necessary. You can get longer ones, whatever. But if you get an integrated lead screw stepper, you're kind of stuck with the same one.
Yeah,
It's
no,
not easy to swap it out.
no, that makes sense. Okay, so we have another question here that just popped up from Nav3D Design. Sorry, it took us a little while to get to your question, but it says force start versus ball lead. Options as in which would be better for 500 mm3. So
All right.
millimeter.
Well, I just got to start off and say I love the machines you guys are building. It's really cool stuff. Part of me says I don't want to give away all of my secrets. You know, I'm in Art 3. Like, we build machines too. But yeah, I'll put it all out there.
Hey, just make sure you don't give out too much and you end up getting canned. I do not want to see that.
Bad information. No, I'm just kidding. I would
give out super bad information.
The best thing to do is M5 by 1 millimeter threaded rod. You don't need a lead screw at all. Just use a threaded rod. No, don't do that. Use proper lead screws. Okay, so here's the thing. At this size, constraint theory really comes into play. Yeah. Oh no. Yeah. You guys are competition. You've got some really sweet machines, and you're in production or closer to production than we are. Then again, I suppose we're kind of in different brackets. Art 3 is in definitely like an industrial focus. You know.
I put Art 3 in the insane industrial end.
We do the batshit crazy stuff just because we can, you know. Nah. Generally, we do things for a reason. There is a method behind our madness. You know, some people look at that machine and they go, "Oh, it's just insane." Well, there are, you know, legitimate design reasons there. So okay, back to the question. Sorry about getting sidetracked there. It's all funny and all, but that's actually a really good question. Okay, so force start or ball screw. So here's the main trade-off. Ball screws are excellent when you want to have high efficiency. They're also, well, because the high efficiency, like low friction, right? They're also good when you want to have really, really long life. Yeah, NAK3D. I might have you confused with somebody else. Sorry. It's, you know, there's so many printer names. Yes. Hey, that's all right. So what was I saying? Oh yeah. Ball screws are better for constant like movement and really high-end industrial designs. They come in two flavors. You've got rolled ball screws and you've got ground ball screws. Rolled is a little lower quality, but these days usually quite good, totally good enough for a 3D printer. Like ground is the gold standard. If you can get a ground ball screw, what that'll do is, yeah, backlash. I'll get to that in a second. Trolling for dollars. That's an excellent. That's really important. That's one of the central things to this discussion. A ground ball screw will be the best. They can hold tolerances that are far beyond our needs. Because let's be frank. In a 3D printer, you're still squirting molten plastic out of a nozzle. You know, there are fundamental limitations to how precise and how consistent you can get with that. In a properly designed system, yeah, that'll be your bottleneck. But at the same time, you don't need to go so overboard with the rest of your design that it, like, you know, diminishing returns, right? You know, you could pour an extra $10,000 into a design and get all premium components, and the print results are the same because the same limiting factor is still present in it. It's like the nozzle, you know. So there gets to be a point where good enough is a real thing. So take it from somebody who has experience designing industrial printers, yeah, engineering one of these things is kind of an iterative process. You go and you look and you knock down all the different bottlenecks until you kind of end up with just the last couple. And you're always comparing, you know, price versus the payoff. You know, how much performance am I getting for this extra money, you know, that I'm pouring into this machine? Because ideally, in an ideal printer, all of the bottlenecks would be about the same, right? You know, you'd have a machine where all the components are performing at the same level. You know, if you have a component that's performing higher than necessary, that just means it's wasted money. If you were to take that money and put it into the rest of the machine, you could raise the overall level, right? Whereas if you have one component in this whole machine that's bottleneck is way down here, you might be limiting the entire machine to this performance bracket, you know. So really what you want to do is just get components that are all good enough that the bottlenecks are all around the same place. Yeah, exactly. We're not talking NASA CNC. You know, we're talking like fundamental limitations of plastic extrusion here, you know. You don't need parts with, you know, sub-micron this and that. In some places you do, but like there is such a thing as over-speccing your components, you know. When our standard NEMA 17 motors do just fine, it really doesn't make sense to buy like a $200 ultra precise medical grade quality NEMA 17 that has like you know, ultra low run out and ultra low friction because the bearings are like super high AVEZ category, and you know, but I digress. In a Z-axis, lead screws versus ball screws are actually sometimes kind of helpful. You see, the friction isn't such a bad thing in a Z-axis. Now, in industrial machines where they're going to be used like workhorses like all the time, a ball screw may make sense because they do have a longer life. But that's not such a huge factor. Like for desktop machines, yeah, a lead screw is fine. A lead screw is fine. However, I would pay attention to one factor. This is kind of an important thing in the price versus performance thing. Diameter and straightness, right? Like, you know, the stiffness of the thing. Ball screws are quite a bit more expensive, and as a result, generally they're shipped pretty carefully and they'll be pretty straight. But always check them, of course, when you get them. A ball screw will tend to be straight enough to use without worry. Like a lead screw integrated motor, you know, you can usually just assume that it's basically straight. A lead screw on its own, not so much. You kind of want to check that, especially if you buy from, you know, just Chinesium stuff. However, there are some advantages to lead screws over ball screws. Even though ball screws last longer and run smoother and a little quieter maybe, lead screws do have some advantages. Like I mentioned, the friction can actually play to your advantage in helping to hold the Z stage up, keep it from falling just under its own gravity, right? Another thing about lead screws is, besides the fact that they're cheaper, you know, you can get them in very, very long sizes if you want. Like you can get a lead screw in like a meter long without breaking the bank. Whereas to get a ball screw that long, you might have to take out a second mortgage, you know. Lead screws are, yeah, commodity items. You know, they're very standardized. They're very easy to make in machine shops. You can get them anywhere. So as a result, there's a lot more of them on the market. You know, you can get them in all sorts of different sizes and specs, and it's easier to get a lead screw that's like exactly fitted to your needs than a ball screw. Another thing, backlash. So this is another important thing. Ball screws can be made to different preload specs. So do you guys know all what I mean by preload? Like Ron, are you familiar with that concept?
Reload, not quite.
Okay, so preload is this idea that a mechanism that can move both ways will need the motion system to have some existing forces kind of wedging things. Like, say, if I wanted to push a block back and forth on a rail, and I had my fingers a half-inch apart from it on either side, there would be some slop, in order to start getting it to move every time it changed direction.
Okay.
Preload is the idea that you can counteract that by squeezing it ahead of time. Then it'll move exactly with you, right?
Oh, okay. So in other words,
Okay.
kind of like when you grab a box, if you just push it back and forth, there's going to be slop in between.
Right.
But when you push your hands
If you
together and
squeeze
move
it with
it
both
back and
hands,
forth, there's
then
no
it's
movement.
going to move exactly.
Yeah.
Yeah.
Okay.
You got it. So that's preload. Now, preload is easier to control on, like, highly precise systems like ball screws. You can get ball screws and other components of similar ideas made to different preload specs. By what they'll do is sometimes one method is they will swap out the balls, and the balls will be very slightly different sizes, and that will pre-compress or preload the grooves so that there's no slop. Another way to do it is to have an adjustable preload ball nut. Now what this does is this has basically two ball nuts rolled into one, and you twist them relative to each other, and that wedges. Now that's really nice because it gives you zero slop, but it also increases the size of the nut, and it can increase the wear a little bit. Not that much, but it's all right. That's similar to the preload systems used on NEK3D. Yeah, it can help with better Z-hop. But here's the funny thing about the Z-hop and stuff. So in lead screws, you guys have seen like some of those split nuts, right? Where you've got a top half and a bottom half, and then they've got like a spring between them, and they compress them apart. That way you've got some that's hitting one side of the thread and some that's hitting the other side of the threads, and it wedges it so the nut can't jiggle. That's a preloaded nut. And they work great. They might take up a little more room than a single nut, but that's all right. They work great in taking out the slop, maybe some mechanical resonance. But the thing is, in a z-axis, where gravity is always pointing one direction all the time, your axis is technically already always preloaded. You know what I mean? You've got gravity, just the weight of your z-axis, pushing down on that nut, holding it to one side of the thread all the time. So the question is there any real benefit to having a preloaded nut? In some cases there are. Here's an oddball scenario. Maybe you're the type of guy who likes to flip your printer upside down once in a while. Yeah, if you had a preloaded nut, it would let you do that. Now that's silly. I mean, I've done it a couple times. It's kind of fun, but
Why?
because you can. I mean, why do people climb the mountain? Because it's there,
Well, no, because people need exercise. That's why.
Yeah.
We all got to get rid of our fat every so often,
That's right. That's right.
So it kills me. Oh, well, whatever.
Yeah. So you could that's a silly example, but it gives an example of the type of thing that it helps get rid of. The next thing to take into consideration, though, is the circumstances under which that helps. Yes, John Mack comments, loop vase. So if you have, and this is just what I was about to get into. Excellent comment. If you have a model where your z-axis movements are really tiny, say maybe it's a spiral vase. You guys know what I mean. A constantly increasing z, where your motor is just slowly turning as you move around the perimeters. It just increments up one layer at a time. No retractions, no travels. For that, kind of edge case of 3D printing, yes, a preloaded Z nut is helpful, and here's why. And also a ball screw is helpful. A lead screw can get a little rough as it's used. There can be a little bit of grit that gets in it from the wear, and if you don't have preloaded, what it does is it can tend to kind of float and skip and stutter and bounce in like a really worn nut. A preloaded one will ensure that it's mashed flat against the bottom. It just adds extra preload aside from what gravity is already doing. So it it can give you better spiral vases. Now that's kind of a side thing. Not everybody does a lot of spiral vases, but that's one thing to know. Ball screws also are really good for that because there's no sliding friction; it's just rolling friction. A ball screw gives you beautiful, beautiful spiral vases because they increment really smoothly. So, another just side note. Trolling for Dollars asks, is 12 millimeter much better for the Z-axis over 8 millimeter? And I would say no, not really. Unless you're building something that's like just insane, just totally nuts. Usually the rigidity bottlenecks for your Z-axis are elsewhere. Think of it, it's a steel rod, it's a steel bar, and your bed is either resting on it or hanging from it. And an 8 millimeter steel rod is pretty sturdy lengthwise, 12 millimeter is pretty beefy, but honestly, for most printers in our size bracket, 8 millimeter is just fine. That said, if I were building something like 500 millimeters cubed, which is crazy, and you have to start thinking about all sorts of other things in that size range. I mean, unless you want printers that are really, really slow, like the CR10 scaled up, you have to do a lot of things differently. All right, thanks for coming, NAK3D.
Yeah, thanks for coming in, man.
So yeah, a 12 millimeter lead screw can give you some benefits, but only in really, really big applications. For anything like 500 and below, 8 millimeter should be fine. What you're more concerned about is the horizontal rigidity of your assembly. 1 meter cubed. Okay, that's a whole nother can of worms there. 1 meter cubed, you start getting into some weird mechanics. You need to think about some things that aren't issues in normal sized printers, because things don't scale up linearly. A lot of things scale up funny. So.
Oh, well, just interrupt you. I don't mean to. But guys, if you're liking the content that we're producing right now, remember, hit that thumbs up, guys. Remember, thumbs up if you like it, thumbs down if you don't like it. Comment below, after the stream is over with. We always like to read the comments at the end, and if you guys got a question, like I said, post it towards us. Tag my name, tag Daniel, then we can see it a little clearer. I'm also going to ask if you guys got questions and you want to be involved. Let me know. We have a link. We can bring you into the channel, and you can ask the questions completely to him and get, if you're not getting the full answer you want, or if you want to voice your own questions, I'm more than happy enough to bring you guys into the chat. So just let you guys know. That's weird. Nightbot just had a seizure. Said support the stream twice. Oh. Go ahead.
All right.
Sorry about that.
Okay. Well, thanks for coming, Trolling for Dollars.
Yeah, hopefully you're loving the content. I mean, Daniel comes in here every so often out of his own goodness of his heart, which I must admit is so nice of him to come in every so often. I think I got you addicted to this, haven't I?
Yeah, you have. This is a lot of fun. I love streaming. It's like I get to hang out with all my buddies. I love it.
Well, I did also tell you, we ran a contest, if you did not know about it, the 100 subs. We're over 100 subs now. So I ran a contest. We gave away 2 rolls of filament of this stuff, which you loved.
Yep, that's right. I found that stuff pretty helpful. You just run a sliver of that through your nozzle, and it picks up all sorts of junk. I mean, that reminds me. I ran some of that 2.85 that you gave me.
Yep.
Through that nozzle, and man, it was picking colors out of there like amazing. It's like flushing it out with a pipe cleaner.
Yeah. No, well, he was trying out my CR10 when we were having issues with the CR10. Oh, I found out something new about my CR10. I'm missing a screw.
Oh, really?
I'm missing the screw for my head. I was wondering why my head was wobbling back and forth. So I cracked open the that shed thing.
Case
yeah.
thing, yeah.
Opened it up, and what am I missing? A screw. Was never put in there from the factory.
Interesting.
So it's a 3 millimeter screw, a 3 millimeter screw. So I've called. So luckily, our friend, well, you know him too, the bear, has one. So he's bringing it over sometime this week for me. So yay!
Hmm.
Be nice to put a screw in there and just finally have it working properly again.
That's right. Well, and those extrusion issues we got to look at, right?
That's true too. Well,
Yep.
it's going to be a full reset of the damn board. I'm going to have to do that.
Yeah, we'll get that figured out.
Yeah.
There
Well,
was one
me and
other
you will be
thing.
on one day and we'll do it. Just Operation Ron's printer needs to work.
Yeah. Um, um,
Yeah. So let's see. The alias that you command is to be of give does not exist. Oh, what the heck's going on? Hey, Chris Riley's in the house.
hey,
Sorry, Chris Riley. I had to do that.
Here, I want to post a little thing. Ooh, harmonic resonance of certain size structures. That's fun. That's a good question.
Okay,
By the
we
way,
know
Chris
we
Riley, I wanna get to know you sometime. You seem like a really cool guy. I've been watching some of your streams. Love your content.
okay. You just hit his love right now for that question. So go ahead, take it on, Dane.
First, I wanna finish up the lead screw questions before we get into this because there's just a little bit left.
Okay.
Remember in the last stream, I had promised a thing about z-axis stuff, like z-wobble, z-ribbing, da-da-da-da-da, and I realized I never gave that link. So I'm going to post that in the comments right now. So actually, that might be showing up a couple seconds before.
No, it's up now.
Okay, good. All right, so that's the thing I was referring to. And one of those deals with the final note on lead screws that I wanted to talk about tonight. So the final bit about lead screws versus ball screws is resolution. So I did a couple personal tests on one of the theories talked about in that Evernote that I linked to there, which is sort of it's a two-part thing. One is inexact, like rounding errors, and then part two is accumulating or non-accumulating rounding errors. So both of those are very interesting, but they only show up when the rest of the machine is tuned to oblivion. Like everything has to be like totally perfect in order to notice them. But if you've got your machine tuned really well, you've got the classical Z-wobble figured out, you've got some normal Z-ribbing figured out, all your temps are stable, all your currents are stable, everything else like that is physically, mechanically, and electrically stable. Then you might see a little bit of this periodic ribbing that you're like, man, I just can't get rid of this. What is going on? This would be a thing to look into. So if you're not printing at layer heights that are a multiple of your whole step size and whole step distance covered, then you can get one of two things to happen. The first is rotor sag will vary. So what that means is at a given microstep, it doesn't matter what microstep it is, so each microstep will generate a certain amount of torque, right? If you're on the whole step, it's quite a bit of torque. If you're on like a 16th microstep, it's not as much torque. It doesn't matter. As the z-axis pushes down on that, and this is more pronounced for ball screws than for lead screws, which can tend to lock under their own friction, the rotor will sag into the magnetic field, you know what I mean, in order to kind of push back against that. And once all the forces are balanced out and all the torques are balanced out, that's where your z-axis will rest. Now, in practice, what this means is if all your layers are landing on different microsteps, that sagging might be different amounts, and it will stack up periodically because every few layers it'll line up to the same one again. So you'll get some layers that are a little taller because the rotor had sagged a little more, and you'll get some layers that are a little shorter. And what that'll do is that'll press out the plastic sideways, different amounts, and that will show up as very, very subtle ribbing on the sides. That's just a microstepping issue. not like a rounding issue, but just like a micro-stepping issue. Now, if you set your layer height to be a multiple of your whole step size, and by that I mean, like, if you set the motor, independent of micro-stepping, the motor, say it's 1/200th or 1/400th of a circle, and then you divide your lead, so not pitch, but lead, by that distance covered in one step is what you'll want your layer height to be a multiple of. Now, what that will do is that will ensure that every single layer will land on the same micro step. Whether it lands on a whole step, oh, that's good, because there's hardly any rotor sag. They'll all have the same amount, hardly any. If it lands on a 16th micro step, it will sag more, but it's all the same. Again, so your layers are all consistent. So I did some tests on that to figure out whether that was the case. And yeah, it's true. If all your layers land on the same microstep, it does increase your consistency a little bit. It doesn't matter so much which microstep it is, as long as it's on the same one each time. Like it does help consistency.
I love Minnesota's maker. He's like, when are we going to start speaking English again?
Sorry, guys. I got really into this. Sorry about the jargon. You can tell me to slow down.
What do you mean by sag? Because between the steps and spindles will be in a lower position. I think that makes sense. Nice.
Sure.
That's according from
what I mean
Chris.
By sag. Oh, sorry. I should go back up. So, trolling for dollars. Degrees. All I've got is just a bachelor's degree. I've been studying this stuff for 4 years, and got started on machining before that, and it just comes naturally to me, I guess.
Your brain's wired
for it. What I
it.
study, you might say my brain's kind of wired for it. I was a Lego kid. How many of you guys were Lego kids?
I think we all were.
Like Legos were. I love it. So many people in these groups are just Lego people growing up, and I love that. Legos are totally the reason I'm into this.
Lego was the maker stuff for kids. I mean,
exactly.
Swear, I used to build stuff and try to figure out how can I make this waterproof. That's how I used to think as a kid.
Yep.
I thought glue stick.
Mindstorms. Yeah, glue stick could do it. Or acetone fluid. You can do that too.
That's true. No, but glue stick, I just found all it did is just let water in after a while, and then it would just eat away. And it's like, okay, well, glue stick doesn't work. I used to pull, like I said, controllers apart when I was a kid to figure out how did they work, the buttons, touching the contacts. That was me back in the day. So,
all right, Chris Riley, I'm glad that made sense now. Yeah, just a little more explanation. If it needs more explanation, just let me know. But
Lincoln logs. Oh my God, I remember those damn things.
Yeah. Yeah. So it's kind of a funny story. Legos got me into Lego Mindstorms, and Mindstorms got me into a Lego robotics team, and a Lego robotics team got me into FRC, first robotics competition, and that was where I saw my first 3D printer. It was a rep strap, and I was changed. Good days. I remember those FRC days. High school robotics team. I mean, 6 weeks to build the whole robot, and we'd be pulling all-nighters by the end. So much fun, and I kind of got a taste of that again with the meetups like Murph and Earth. It's like the competitions or the festivals. You go and everybody's amped up on Mountain Dew and showing off their printers, like their robots so excitedly. I just have so much fun with this.
That's what you should do for Murph this year. Yeah. Build yourself a competition robot.
Hey.
Fighting robot, have it off to the side, show it off to everyone.
Yeah.
See what they say.
Let's see. What else? Was there something else I was...
Nothing yet. Really.
Okay, so I think...
Did we get into the part that was asking about the harmonic resistance?
Yeah, harmonic resonance. I'll get into that in 1 second. There's one last bit of that article. So aside from the microsteps, there's one other thing, and that's that the article talks about non-accumulating rounding errors. And in my experience, this hasn't been so much of an issue. It's a very minor thing. You might see this on 8-bit boards. I think 32-bit boards wouldn't have so much of an issue with this because they deal with long decimals much better. But what happens is you can have, like, especially if you set it to layer heights that are just like really not a multiple of the lead screw type, or sorry, the hole step distance, like an irrational multiple of it. You can have rounding errors that, like, every 9 layers, usually 9, will show up, and they'll all be the same size, and then you'll get one that's a little shorter, and then they'll all be the same size, then you get one that's a little shorter, and it can make just like ridges, very slight ridges on this side. That's been more a minor thing, but okay. So where does this all tie in? If you look at the popular combinations of lead screws and motors, the most common one for Z-axis is a TR 8x8. That means a trapezoidal Acme profile, 8 diameter, and 8 lead. Now that is a 4-start, 2 millimeter pitch times 4 means 8 millimeter lead, and that means the distance that you cover in 1. You pair that with 200 step per revolution motor, and you find that your whole step distance is 0.04 millimeters, which is not a very nice number. 0.04 millimeters, like, that's, you know, your awesome layer heights then are 0.04 or 40 micron, 80 micron, 0.12, 0.16, and 0.2, and so on. Your numbers like 0.1 and 0.15 and 0.05, they're not in there. So you might notice a little bit of extra banding if you do those with a TR 8x8 lead screw. That's why I like TR 8x2 lead screws so much. TR 8x2 means single start, 2 millimeter pitch, 2 millimeter lead, and the whole step distance on that is 0.01 millimeters. So any lead screw, any layer height that you can express in just 2 decimal places will work perfectly with one of those. Now, the problem is they're not as common. For some reason, everybody decided TR 8x8 would be the standard. I don't know why. And now TR 8x2 is kind of harder to find. And it's hard to find a motor with, like, a lead screw integrated motor with a TR 8x2. What I want to find me is a set of lead screw integrated motors with, like, really long, nice TR 8x2 lead screws integrated into that. That would be sweet. If I could get 3 of those for a printer build, it'd be pretty sweaty.
Yeah, I like Chris Riley's line. We need to form a BattleBot team.
Oh, we have the talent. We'd be so good.
I can see it now. It could be called Art's Basement.
Yeah.
Take Chris Riley's basement and take you as Art 3, Art Basement.
Well, I'm just a third of R3. Oh,
Yeah, but
Art, yeah.
you know, you get Jacob involved.
Yeah. Oh,
You
Jake
get Chris
would have
Riley
so
to do all
much
the.
fun with this. He would have a blast. Grant too.
Oh,
Grant
probably.
got some nice printers.
That's if Grant can break away from his printing.
Yeah. Oh,
And we'll go into other stuff. Like, I've already talked to Daniel here about a couple other ideas we have for the channel. So as we go on, it'll grow and grow and grow. And I do know that I got locked on Daniel right now. So we'll lock it back into me. Grow and grow and grow. But yeah, we got some plans. And yeah, Daniel's going to be helping out a lot. So I'm glad to have you, helping so much.
Glad to be here. This is so much fun, you guys.
Yeah, if you guys want to support the channel, remember, you can always hit Streamlabs. Throw a couple bucks our way. It always helps. Unfortunately, you won't hear any noises because I'm not on Streamlabs. I just got the regular YouTube chat thing on, but that's about it.
Okay, we got another
So-
question from Chris Riley here.
Yeah.
A 2-start lead screw, correct? No, single start. So a 2-start would give you a 4 millimeter lead. Now that would have your whole step distance to 0.02 millimeters, which would double your number of acceptable layer heights, or ideal layer heights, I mean. So now you could do anything that was an even number. You could do 40 micron, 60 micron, 80 micron, 0.1, 0.12, 0.14, but not like odd numbers like 0.15. Single start lead screw would be ideal, because then you really get better resolution. Also, side effect of having fewer starts, your pitch is steeper, right? Not steeper as in like axially steeper, but I mean like it's flatter, which means that more of the lead screws, like the nut's force, is turned into friction or holding. A TR8x2 lead screw is essentially impossible to back drive. Like its mechanical advantage is so high and its efficiency is so low that a Z-axis made of TR8x2s basically doesn't slip. Just in all practical experience of mine, you can't like just push on them and get them to slide. Yep, yeah, Chris Riley.
Okay, so with that being said, now just thinking about this, just got me back to stepper motors and Z-axis question. So if your motor is mounted at the bottom to drive a shaft up, why wouldn't you want to mount the drive at the top and have it control your Z-axis? Or is
Yeah, you can do that too.
is there any disadvantage or advantage?
Not really. Here, just a second, guys.
Yeah, dealing with he's at the makerspace again, guys. So you know he has to talk to people and get stuff taken care of. But yeah, no, it just popped in my head because I remember seeing a couple of drives set up that way, where your motor's at the top and it pulls your plate. In a Core XY is what I'm thinking of. But yeah. Hey, you know what? I try to share as much as I can. I try to give this guy, you know, his own stuff, but he's enjoying himself just being on the feet alone. So, yeah, here he is. I think he's back now.
I am back, you guys. Sorry, just getting a notice from one of the other guys here at the makerspace. I'm sitting in the makerspace right now.
Yeah, let
I'll
them know
close
what
down
you're doing.
in an hour.
Okay.
So.
Well, he'll still be on, but yeah.
I'll still be on. I just he was just letting me know. So here we go. Oh, thanks guys. Thanks Apocalypse Survivor. I love sharing my thoughts. Glad it's helping you. Chris Riley has a good point. Yes, Z-lift would change somewhat. So if you have couplers, yes, a helical coupler, if you're mounting downwards, will bounce, which is one of the main reasons why like the earlier, like the i2 design, which had the motors mounted up top, was flipped and the motors were eventually put underneath, because that way it works. Because helical couplers were kind of the de facto standard then. However, even more on that, like plumb couplers or spider couplers, they would just flat out fall apart if you had them sitting at the top, But an integrated lead screw motor, no, that would work really well on top. In fact, that's what I'm planning on one of my new designs that I'll be working on later this summer. It's not on my priority list right now. It's just something on my back burner that I want to do eventually. And it's going to use 3-point leveling, actually like true motor tramming, with the motors at the top. And that's just to minimize the length of wire runs, is basically the only reason for it. The other thing is the weight of the, and this is a minor point, but if you imagine, you kind of caricaturize, make into a caricature, the flexibility of everything. Imagine that these lead screws are kind of flexible, because in reality everything flexes, but imagine they're way more flexible than they actually are. If you have a Z-axis sitting on top of them, you're kind of compressing them, and if you imagine that they're a wet noodle, they'll bow a little bit. In reality, that's not much of an issue, like maybe a micron, I don't know. But if you have them sitting at the top, a Z-axis will tend to straighten the lead screw a little bit. Again, not a big issue, maybe like micron scale, but could be helpful. That's funny. You sponge, you fire hose.
Yeah, that's why I went LOL. He just tries to absorb everything, but all of it. But once you absorb so much, trolling for dollars, it just goes. Oh, it just gets. You just can't absorb it anymore. I get it.
Well, that's why we have these weekly.
Exactly.
So you could rest.
Maybe we should bring these
into the chat. Recommend this to your buddies and
yeah, guys, if you're out there on Twitter or anything like that, uh, post it out. Pound CMP if you want to. Pound 3D printer, 3D making. Pound, I guess. 3D talk, really. This is all about 3D talking, and talking about 3D printers and taking it to
Hmm.
the next level. Actually, Daniel, I got something for you, but I think this will be more Jacob's end. Talking with our friend the bear, I came up with this design here, and this was just done on paper. It wasn't meant to be anything
Okay.
spectacular. Let me see if I can pull up the picture here, show it off in the camera.
All right.
This is something I'm looking at designing. This is just for a light that I was looking at hanging from my ceiling. Let me see if I can turn this the right way.
Here, I got to
Just
make
gonna
sure you're the one who's
allow it. Yeah,
uh,
no, I'm gonna fix that in a second.
casting. I think right now you're
Yeah, there I am.
zoomed on me for some reason.
That's the dimensions I came up with. Hopefully that shows up well.
Ah, yep, got it.
So the idea I was thinking of is I thought I need to have the triangles inside the actual triangle frame to hold up the weight that I'm looking at. I don't know how much the weight is going to be. Is there a way that you can calculate weight for how much you would need supports in that, or would it not need the supports because it has the supports in the infill?
Yes, this, okay, now this is where we get into dun, 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 structural modeling and finite element analysis, and this is what I went to school for. You can do stuff like statics and dynamics, deformation of materials. You can run these calculations if you know stuff like uh, the cross sectional area or the second moment of the area of the part, and you can run a beam deflection calculator on it if you can integrate along the varying area and the varying second moment of the area. You can exactly calculate ahead of time what your beam deflections will be. Yep, static engineering, trolling for dollars, got it.
Yeah.
Um, a long, widely respected profession. It's seems like rocket science to a lot of people, but I mean, people have been doing this for ages, like ever since calculus was applied to engineering. Um, so yeah, you can absolutely do that. A lot of engineers can do these calculations. Um, However, once you get to trusses, it gets a little more interesting because you're dealing with multi-part scenarios. A lot of people in statics and dynamics and then deformable body mechanics are taught how to do that with like pin joint. Um, it's a little harder to do that with um, like fixed joint things, where the beams are kind of like structural. It's a
Yeah.
little harder to exactly do it, and it's even harder when the material is not homogeneous. It's made of strands, right? That's when stuff gets a bit harder.
So that design may not or may work.
It can be made to work. I'll put it that way. It can definitely
Okay.
be made to work. It's just going to be a little more difficult to calculate, like ahead of time, exactly what it would take to make it work.
Oh,
Um,
okay. Like I mean, when I was talking with the bear, as he likes to be called, his nickname was, he was saying that the trusses aren't really needed as much as it would be that you already have the triangle there. It should be enough to hold the weight, which I went, it
that's
might.
right. That's
It
right.
being its own triangle, it should hold the weight. But I'm thinking but then again, how do we limit the amount of plastic we're printing out to make it light enough that I'm not wasting hours printing? You know what I mean?
That's the question. Here, I'm going to do something fun. I'm gonna show you. Mind if I screencast? I've got a
Go ahead.
nifty process I can show you guys. So I'm just gonna minimize everything here. Sorry, working on some Marlin firmware at the moment. Um, I'm gonna bring up Autodesk Inventor. I've got my
Ooh.
nifty 3D mouse here, and I'm going to do a little bit of um, modeling to show you one of the ideas that I have in mind here.
Yeah, it's Inventor's $1,000 program, guys.
Yeah.
I have a copy of Inventor. They sent it to me to try. I was like, what?
Yeah. So here's so yeah, okay. Let's see what we're dealing with here. We've got like some shelf, and then we've got there, and then we've got there, and then we've got so we've got this here. I don't know what your dimensions of this thing are. Would you mind giving this to me?
Yeah,
The
let me
overall size?
see. I had it written down at 1 foot for length. That's what it came up with. I figured we would be about the right type of length.
Okay.
I figured out 3 meters from the 3 meters was going to be the back plate for the back where the triangles would connect.
Okay.
I don't have a length for that, unfortunately, because I didn't calculate that.
What's
But
the
it was going to be
overall
about 3 meters thick, and I was looking at 10 meters. Was it 10 meters? I said
10
thick.
millimeters.
Yeah, 10 millimeters thick by 3 millimeters height for each connection for each of the
And what was
connecting.
the overall height of the thing?
Overall height, 1 foot by length, and I didn't really calculate the height of the end of that yet.
Say it's like maybe 6 inches, and this is like what? 3 millimeters. This is also. You know what? Let's make it all metric. I'm gonna do 300 millimeters for that, and I'm gonna do 150 millimeters for that.
Okay.
All right. So say we've got this, and we're gonna extrude it. What was it, like 10 millimeters?
I said that for 3 millimeters for extrusion, actually, if I remember correctly.
Okay. So I'm gonna do 5 millimeters because I'm gonna show you something nifty.
Okay.
The shell tool. So if we do it should work. Here we go. So what I did here, if you can see, is I hollowed out one side, right?
Yeah.
So basically what we have is a triangle that's very, very hollow, very, very slim, and it's got this kind of a rib, honestly, connecting the sides, right?
Mm-hmm.
You know what I mean by a rib. So next I'm going to go in here and I'm going to smooth out every single one of these lines, the edges. Whoops, not that one. This back here is not what I meant to select. This one is. And that was too tight, Maker, so I'm going to have to go in and fix that.
Oh, I know what you're doing.
Here we go. So here we go. Sorry if this is making you guys motion sick. I'm a bit used to it by now, but because I'm the one running the 3D mouse. So, all right. So what this does, the fillets avoid stress concentrations, and what that means is sharp corners are where stresses in the material will tend to build up and break the material. So filleting ensures that those stresses are a little more evenly distributed. So okay, here we have a part. I'm just going to highlight both of these so you can see. See what we're looking at here? It's got a very thin triangle around the edge, and then it's got a rib that's basically, thickening it or is connecting it. But the majority of this side is kind of cut out. That ensures a lot of weight saving. In fact, this thing barely weighs any more than if it were just the thickness of that rib. The thickness of this outer shell is not very much. Just from here to here is like 2 millimeters. But it's actually substantially stiffer than if it were that because of the higher second moment of area. So that gets into kind of statics and dynamics type stuff.
Okay.
Now we're back. So that's kind of how I would design that. Probably, honestly, sheets. Sheets can be very, very sturdy for the the thickness of them.
That's what he was talking about, was that we have to do it in sheets. I'm like going, huh? You know, like that part of the CNC part gets me confused. I'm so used to doing it on paper with a pen and doing the calculations when I'm doing measurements when I'm building with wood. That is what I'm used to. You know, going to the 3D building, it's a little bit of a different think that you have to go through. Bringing circles into a triangle is what Chris Riley said.
Yep.
Yeah, and I understand why you would want to round off those areas, because that would give it more structural strength.
That's right. That's right.
Yeah, and that's what I was thinking too. Like, how do I make that? And that's why I was thinking trusses instead of thinking, oh, circles. Yeah, why did I think of that?
That's right.
And then when I saw you highlighting that area, I went, oh, you're rounding it off so it has more structural strength.
Yep. That's exactly what I was doing. Rounding that off avoids stress concentrators.
Yeah.
So I'm just CADing up an extra little interesting bit here that might interest you guys. An extra thing you could do to increase load bearing capacity. I've never done like CAD demos or anything before to show people. So.
Okay, let's have a look here.
There you go. Right. By the way, anybody wondering my CAD background? I had 2 years in high school of professional like CAD training on Autodesk Inventor, yeah, I learned a lot, loved it. I've been doing it for quite a while. Have been doing it very, very frequently since then, just kind of for fun and obviously for, you know, my job and stuff now. So, okay, I am gonna head back to this stream again here. I'm gonna screen share. All right, can you guys see this?
Yep.
Here's one other thing I added. So see this extra rib in the middle?
Yeah, I see that right there. Yeah.
So what this does, this would say you've got a sheet or a shelf or something, right? That's sitting on top of this whole thing, and you want to transfer its weight down into the wall here. This would take the midpoint and offer a nice short path of, you know, strong, kind of just a solid beam, taking that force and redirecting it straight into the wall. This would also give you, you know, like if you had more mounting points, like you could have 3 sets down at the bottom, halfway in the middle, and at the top to screw into the wall. This would really increase that. Also, one thing that this will do is this will stiffen up the rib in the middle, right? This flexible, kind of thin back plane. This will stiffen that and keep that from bending. So, yeah.
Okay.
That's
now,
a trick I would use.
Going into triangles being the strongest type of mathematics and all that, but aren't you forming more of a square with that, a rectangle, than a triangle with the second half?
Good point. So yeah, the bottom right hand in that case, right, is now a I'm totally blanking words. It's not a parallelogram. It's just a recto. Why am I having a brain fart now? This is an easy word. I use this like every day. Yes. Yeah, trolling for dollars is right. It depends on if you're dealing with 2D or 3D forces. If you're dealing with 3D forces, you're going to want like a 3D space truss. Not quite a rhombus, just a 4-bar figure. Quadrilateral. Here we go. So yeah, it's quadrilateral, and a quadrilateral on its own is able to flex. But remember, we've got a sheet in the middle, right? Now the stiffness of a sheet is like, you know, to the 4th power. It's very high. A sheet has a lot of stiffening force. If you take a quadrilateral, which would ordinarily be able to flex, and you throw a rigid sheet across the back of it, it's suddenly very, very rigid. So that's okay in this case.
Yeah, I'm just seeing if anybody's posting with pound CMP. I'm seeing a lot of weird pictures for pound CMP.
Weird.
Oh yeah. Pound CM Punk. Not just CMP. Yeah, some weird stuff being posted. Pound CMP.
But only intention, yes. Trolling for dollars, you're correct. Only intention. A sheet that's thin is not able to withstand buckling forces. However, the way a quadrilateral works out, and this is the neat kind of hack, whenever it flexes, one of the axes is going to be in tension, right? The other one would be in compression. So a sheet would not be able to resist the buckling forces, but it'll be able to resist the stretching that the other two vertices are getting when they're against each other. So that's how a sheet is able to stiffen an open side. It is not going to be helpful really in compression. You need more bars to do that. But it will stiffen it against flexing because one of the axes is going to be in tension. So that's the way that it helps you.
So you guys are just putting some stuff out?
You know, maybe we should talk about frame resonance now. We could finally get to that. Chris Riley
Yeah,
still
because
in the
Chris
house?
Riley was asking you about that.
Yeah, it was quite a while ago.
Sorry, Chris Riley.
Okay, frame resonance. You know, this is a great question, and this is honestly a little bit above my pay grade. Like, this is where I'm still learning. I'm not afraid to say that. Like, I'm still learning about this stuff. You know, I dabble in structural engineering. I know a bit, but I'm not afraid to say I'm by no means an expert in this stuff. However, I do know some of the basics. I know some of the tools that we have to analyze stuff like this. There are frame analyses tools in Autodesk Inventor and some other high-profile CAD softwares, you know, high-dollar stuff, that can let you test like the dynamic stiffness of like pipe structures and frame structures and trusses. And a 3D printer is kind of an interesting one. You see a couple different basic categories. You've got your deltas, right, which are one thing, but then the Cartesian, which we'll probably focus on. You've got your like I3 styles, right, where most of the stiffness in question is the square like top frame and the square bottom frame, and then you've got your box frame, you know, some style or another. Maybe it's a Core XY, maybe it's an H-bot, maybe the XY gantry is stuck at the top and the bed raises, maybe the gantry raises and the bed is stuck at the bottom. You know, all sorts of different architectures that can fit inside a cube. But a cube frame is nice for resonance because all the sides are the same. They've got just a couple different modes of vibration. You know what I mean by modes, like vibrational modes, Ron?
Yep.
Okay, so yeah, vibrational mode being like the type of vibration that it's undergoing, whether it's, yeah, John Max got a fun idea. That would be awesome. Now, if you could find, like, maybe print a model where the infill takes the same amount of time, you know, as the period of the bridge, you can make the printer just like shake itself out of pieces. Yeah, harmonic resonance. You've got different modes present in the frame of a printer. Maybe you've got one mode of just maybe an aluminum T-slot piece has one twisting mode. And then you've got like the overall frame can twist this way or twist this way or twist this way. Maybe some of the gusset plates are weaker than some others, and it'll be more prone to one or those than the other. Maybe it's the motion components. Maybe the motion components themselves, like the linear rails or whatever, will be the primary source of vibrational modes. Maybe it's the gantry. Maybe the frame is super solid. Yeah, Chris Riley. Now we're going back to Tesla death machines. That's right. He was working on one of those, right? Like a a little shaker that found the resonant frequency of a building and like supposedly shook it, an earthquake machine. Theoretically possible if your losses in the material were low. If the material had very low dissipation, you could theoretically do that, but it doesn't really work that way in real life. So, trolling for dollars, that sounds interesting. Can you share more about that? So, where was I? Oh, yeah, vibrational modes. So, the other types, other than like rotational modes, are just like shifting modes. Maybe you've got a 3D printer with the gantry up at the top and it's really light, but the accelerations are high, the forces are high, whatever, and it bounces like back, left, and right. Your whole machine might tip kind of like as a parallelogram, right? And if it does that, you'll notice a little bit that say you're just beginning a model. Excuse me. Say you're just beginning a model and the bed is at the top of the machine. It's all going to shift pretty much together. Not much of an issue. But as the bed gets towards the bottom, the gantry is going to shift more than it, and the nozzle might kind of bounce more on the model, and you might notice more ringing than at the beginning. Now this could be differentiated from belt ringing, which is usually what you get. That's usually the main cause of like mechanical resonance is actually in the belts and the motion components. That will stay constant, the whole size of the print, as long as like the moving masses aren't changing and the forces aren't changing, because that bounce will be the same at the bottom versus when it's at the top. Now, if it's frame-based resonance, you might notice it changing as the print size, print height increases. So that's kind of all I have to enter on that. Really, the best practice is just overbuild. Just don't worry about it. It's cheap to overbuild your frame. Make that nice and sturdy so you don't have to worry about frame resonances being too big of a thing. Now, if you're using an architecture that's not a cube frame, cube frames are easy because you can just like slap rigid panels on the side, and that stiffens the whole thing up a lot. But if you're working on a frame type like an i3, perhaps, where it's not like that, what you might find yourself having to do is put like rigid braces. You see those on Wanhao i3s. There's some on CR10s too, where they'll like triangle brace the front and back so that the square frame, you know what I mean, Ron, doesn't like bend forward and backward as the print shakes. That's kind of a minor form of that. Usually the resonance that you get on a printer will be the belts. And that's just because we all use really cheap belts. Oh, trolling for dollars. That sounds so cool. Yeah, you're using like, frame analysis and statics and dynamics. That's so cool. That's perfect. So you've got to model point loads and figure out how those forces will be distributed around everything else. That's awesome. That's awesome. You're solving like matrices, right, to figure that out?
Yeah, sorry to yawn there, yawning for everybody. Ay. Just wanted to say sorry.
Apocalypse Survivor has a
washer versus dryer?
Oh, washer versus dryer race. That's hilarious. That's a funny video there.
Oh, okay. Washer versus dryer. I'm not getting the reference, but
it's a link.
Oh, okay.
That somebody sent. Let's see. Oh, dang it! I lost the stream. I gotta go back. Yeah.
Oh no, you lost the stream. Remember, you don't cross the stream. Just make sure you don't cross the streams.
There it is. I'm back. Yeah, before computer programs, you got to do that all by pencil and paper.
Yep.
Made me do that in school too. Yep. Kind of.
Imagine trying to do that without a calculator.
Oh, but you got to use slider rules. You can't do that by hand, like arithmetic. Take all day. Like that's nuts, man. There's a lot of math. A lot of math in doing that stuff.
Oh, I can believe it.
Mm-hmm.
But yeah, so what else should we dive into? Got a question for you then. Shooting off the idea. So, if for a normal printer it's about 60 to 80 on a gantry for a gantry printer to go back and forth, why can a delta go up to 100?
Okay, good question. So this touches on a couple different things. And first of all, I would like to make sure that we all remember the distinction between um, top speeds and accelerations. Um, Chris Riley has a point here, yeah.
Yeah,
So
you just
there's a
brought it up.
point
Yeah.
where you reach a resonance on a certain axis, let's say x is really not transitional. It's the point where you can't achieve a certain acceleration due to resonance generation. Yes, well, everything is on a spectrum, right? Um, it, it's not like it happens all of a sudden. It's a slow building thing, and the ringing forces or the ringing effects will be proportional to the forces and how fast those forces are applied and not applied anymore. Um, so, let's see, how do I say this?
Yeah, once again.
Yeah.
Hey, Chris Riley, please check your email immediately. I sent you a link to join us in the call.
Yeah, it'd be nice to have you on. How we can chat.
Yeah, so as soon as so check your email. If you can jump in, that would be great. If you can't, just let us know in the chat. But we'd like to have you on if you can. And why I got this weird echo all of a sudden?
I don't know.
It just came and now it's, well, I still have it somewhat. Do I have my
Well,
echo
let's
on?
talk about top speeds. Really, all 3D printers are capable of 100 millimeters per second. I mean, you can hit that on travel speeds, so like theoretically, you should be able to hit that in printing moves, right?
Yeah.
Realistically, like basically every 3D printer is capable of like 200 millimeters per second travel speeds, as long as the hardware is like standard. Really junk printers like the 101 Hero or stuff with really underpowered motors like maybe the M3D Micro, those are exceptions. Stuff with really high friction, again, an exception. But like the vast majority of printers are like just decent. And if you're working with decent hardware, you can push like 200 millimeters a second travels. You can do that.
Well, I can't join at the moment, so
Well, bummer.
yeah.
We'll have you on some other time.
Yeah, definitely we'll have to get you on, man.
So the question then is, why can't we print at like 200 millimeters a second? If the printer can top out at that speed, why can't we, print constantly at that? Well, direction changes. We constantly have to swap the nozzle around. You're changing directions all the time. And especially in detailed and organic prints, you spend very little time at print speed, and you spend almost all of your time accelerating and decelerating. And this is where deltas are really nice. So, two things about a delta. One, because the print is not moving, the plate is not moving, like the only moving part is this light central end effector. And two, because you've got 3 motors working together to move it, and the mechanical advantage is pretty nice. Even though it's not isotropic, it's generally pretty good for most of the print bed. The effect is that acceleration is much easier for a delta to do than for a Cartesian with equivalent hardware. Deltas are usually Bowden. That also definitely helps lightening the moving parts, increasing your dynamic stiffness to weight ratio helps. So decreasing weight helps. So that's why deltas are so often Bowden. Well, one, because it's hard to cram all that stuff on there, on that little end effector. And two, because it does give you really nice speeds. You're hardly carting out around any weight, which means that since you've got 3 motors working together to move that end effector, you can push really high accelerations. So just to compare, a typical, say, 200 millimeter-ish class 3D printer size, like a Prusa i3, might be pushing accelerations of like 2,000 to 3,000 millimeters per second squared, maybe. And jerk approximation to be like maybe 10 to 15 millimeters per second instantaneous direction change. A delta with equivalent hardware, like equivalent motors, equivalent belt lengths, and all that, would probably be able to push like twice that, like maybe up to a G even. Yeah, instantaneous direction changes that are like 20 to 30 millimeters per second. Now, whereas on the other hand, to make an XY gantry capable of those same things, you need to be really working. Ultimakers are capable of that, but you really have to try. An Ultimaker or a quad wrap, also seen on like the Zortrax printers, the raised 3D printers, the Wanhao Duplicator 6, those ones where they've got crossed gantries, I've also heard it called. They have really, really low moving mass and isotropic inertial properties. What they do is, again, if you have a Bowden extruder and really light moving masses, yeah, you can hit those same like levels of acceleration. You can hit like a G of acceleration easy, and like, yeah, 20 or 30 millimeters per second jerk speeds. But those are more expensive to build, harder to align, and all that. So the takeaway from all this is, just because of the mechanical nature of a delta, it's easier to build a cheap delta that can hit high accelerations than it is to build a cheap Cartesian printer. You can build a Cartesian printer that does the same accelerations as any delta. You know, you can build any printer that can hit any accelerations. It's just a question of how much money will you have to put into the components, right? It's always a cost versus performance trade-off. You know, if you told me, you know, I want you to build a delta printer that can hit 5 Gs in like, you know, 1,000 millimeters per second top speed, I would go, I can do that, but I don't know how much money it would take. I'd have to run some cost calcs. Or if you'd said, you know, I want you to build a Cartesian that can hit 5 Gs and 1,000 millimeters per second top speed, which, well, I actually did that, but yeah, it's an entirely different set of cost calcs. And just, you know, sometimes one architecture might be better than the other. You know, it's just a matter of how much money to throw at the thing, you know, how much hardware you need to make it work. But yeah, so for cheap hardware and standard stuff, a delta's mechanical arrangement lends itself to higher accelerations, and that means you can spend more of your time up to speed, which means you can have shorter prints. Even at the same print speed, you can have lower print times because less time is spent slowing up, or speeding down, slowing up, and more time is spent at the target speed.
Okay. That makes sense. And I just love Trolling for Dollars. It says you need to change the title to Masterclass with 3D printers. Well, maybe we'll build a mastermind on 3D printing.
Yeah, I don't know.
It's a possibility.
I should mention, I give 3D printing lessons here in Mankato. So if anybody watching this is from southern or south central Minnesota,
really,
drop on by the Mankato makerspace on Tuesdays. I'm leading.
You give lessons?
Yep. Basically, I just answer questions, whatever people want to learn about. You know, that all interests me. So I teach.
Maybe we can make you some more money by selling you out.
Yeah. Yeah. I mean, I usually try to start with a curriculum, but by the end, people often just kind of have their own questions, and I just love answering. You know, how do I put it? You can talk at people, you can deliver, you know, information to people, and they can learn from it. But really, what they want to learn is going to be the thing that's going to get the most interested and engaged. And if they're engaged, they're going to learn better than if it's, you know, some perfectly theoretically prepared, you know, presentation. If they're interested and they're engaged, they'll learn better, even if I'm just a little bit off the cuff. That's my outlook on things. Just really know the source material, and then when people ask questions, just try and engage them, meet them where they're at. You know what I mean?
Okay. For people who have headphones on, you might want to turn down the volume just a few seconds. I'm going to have some fun here. Okay, I got into Sin 2. That one? No. That one? No. Damn it. Trying to find the no, I'm trying to find the right frequency here.
Hello? Okay, that's the volume.
I got a chipmunk voice.
Pitch.
That's what I was looking for. Sunday, and only on Sunday. Join the maker class. Teach by Daniel Honorson. Only for the low price of $99.99. Classes are filling up fast, people. Order now.
And that's not all.
Oh.
Order now and you'll get free shipping.
Free shipping with every order.
Just drop me off at your doorstep and I'll just like fix your printers for you.
That's right. It comes with free shipping. No,
That's right.
no. I'm not saying we should do that. But what I'm thinking is, with your knowledge and everything else, as you were saying, it is, we should look at some way of helping you out. Yeah, because I know you're not working right now,
Yeah.
right?
I start work again on Wednesday.
Oh, so you got. I thought you said you weren't working at all. Like you didn't have a job, or
Right,
did I miss
right now
you?
I'm not. I do. It's funny. So I had an internship last summer with a local place, and they wanted to bring me on again this summer. So starting August 1st, just for like bookkeeping purposes, I'll be brought on again. So then I'll be working full-time.
Oh, okay.
So
Yeah,
we've
it's only a
got some
6-hour
time
drive
to-
for Chris Riley.
Yeah, that would be a bit of a drive. Minnesota Maker though, come on down. And I tell you what, do you get KEYC News 12? I don't know if you get that station. I'm going to be in their studio Tuesday morning at 6:30 a.m. recording a little bit. They're going to do a news article, a news bit on me and my 3D printing series, and I'm going to plug that and plug the makerspace. So maybe if you're local enough, you could tune into that. And yeah, come on down on Tuesday night. I would love to have you guys there.
Yeah, then Daniel can post a picture on Instagram, and we can fire it around the Twitter sphere.
Trolling for dollars. I don't know about recording them and posting the video. Sometimes there's like personal content. People would talk about it's just kind of like small talk, like people's families and like people I know. So like we'll chat about personal things. I mean, I suppose we could edit them and like trim those bits out and just keep it like really focused on the 3D printing. But honestly, like bang for your buck, this sort of online streaming is probably more
the best. Yeah.
focused. Because like you guys get to ask me questions in real time and like I can respond back to you.
What we'll do, we'll get him a whiteboard. We'll get him his own chat. We'll get him his own time that he comes on the channel and have him just do a sketch up on a blackboard or a whiteboard so you guys can follow along. And then he'll have tests that he'll mail out to you via email that you have to finish within 12 hours, and then he has to go and mark them.
Following this content.
Exactly.
Print this thing with no supports.
Yes.
I dare you. 80-degree overhang. And go. Hey, it's possible. You can do that with a 0.4mm nozzle. I've done it.
That's true. You could.
It's tricky.
But,
trolling for dollars. I'm so glad. It just tickles me pink when people enjoy this stuff. I just love talking about this. As long as people are listening and enjoying it, I'll keep talking.
Like Riley, you probably would receive a B. Probably a B, not a C.
I know.
Definitely a
Maybe
B.
an A. This guy's smart here, Ron. I don't know. I think he's trying to get there.
Well, he puts himself so low. That's why I gave him a grade up higher. I thought,
Yeah.
be nice.
Oh, that's the other thing. He's humble.
That's true too. He is. But no, I love. You know what we should do one day?
Yeah.
Just saying, we should both buy a printer, the same model, and get the Bear on the same channel, and have all three of us put together a printer.
That'd be fun.
Yeah, let's see who we'll make it a race. Who can get their printer up running first and not crash?
Yeah, racing, right? We got to make it a competition somehow.
Yeah, exactly. I've seen Chris Riley and Country do it. They built both Ender 3s, so.
That's right, yeah.
We'll look around, we'll find a cheap printer, maybe $199 budget we'll look at.
You know what I should do?
Chris Riley, you want to be involved too? Okay.
Here, I want to show you guys something real quick.
I think you beat us all, but just saying. Why am I receiving this weird echo?
This isn't the one. I'm checking for my 2.0. There it is. I'm going to share my screen for you real quick.
Hang on. Are you guys hearing the echo? or not in the stream? Are you hearing echo, Daniel, or no?
I'm not hearing an echo. That's odd.
I'm getting an echo from something. I'm not sure what's giving the echo, but I'm hearing it on my end. Guys, in the chat, are you guys hearing an echo right now?
No echo? Okay.
No echo. Okay, good.
That might just be you, Ron.
Weird. I don't know.
All right. Well, I've got something interesting to show you guys. So I'm sharing my screen here. Whoop.
You got both videos open?
Okay. So here's a 3D printer I've been designing. This is one current iteration of it. I'm actually going to go back a revision. Let's see, what should I do? Probably.
Is this the one that you wanted us to name to T-Bot or something like that? We're having naming competitions?
It's kind of a version between this and this is what I'm currently looking at.
Let me pull it up here so they can see it
yeah.
better.
Can you all
There
see
we go.
this screen that I'm showing around? Got to check on the.
Might take a little while, but I can see it.
Okay. Oh, his volume is louder than mine. Yeah, I have a headphone mic, and it's a little distance away from my mouth. He's got a real mic.
Yeah.
Okay. Anyway, so yeah, this is a printer I've been designing for our makerspace. It's almost done. So close to done. And it's going to be sweet. I'm actually going to try and have it working by Tuesday morning, which is going to be a bit of a stretch, but I'm going to give it all I got. So the idea behind this is it uses like all the same components repeated. All the beams are exactly the same length. All the belts, both the belts are exactly the same. All the motors are exactly the same. All the idler pulleys are exactly the same. All the fasteners are just like, there's only like 3 different types of fasteners in this whole printer. And because of that, you can just like buy a bag of stuff in bulk, and it ends up being quite a bit cheaper to build than another, maybe an equivalent printer.
Okay, now we can see. Oh, you're bringing your
You
pitch
can
back.
see me?
Okay.
Okay.
Yep, we can see you now.
So that would be a fun one to do a speed build because there's no like sorting of parts, you know? Right? Isn't that always what gets you though? Like you get this kit and it's just like, let's see, I've got a 3mm bolt. I've got a 3mm. Well, crap, they're like 2 millimeters different length, and I got to use the right one. Which is it? You know, there's none of that with this thing. It's all just like either this bolt or this bolt, and you can very clearly tell the difference. Kind of intuitive to put together because everything kind of only goes together one way. So.
Yeah, I can see it now. Daniel being way ahead of us.
Hey, I designed it. I better be faster than you guys. Heck, I had this thing completely designed in CAD and all the 3D printed parts designed, and it was even starting to print them before I ordered most of the parts. So I assembled it in like 2 hours. Had it working, XY at least. All the functions were working. It didn't have a Z end stop, so it wasn't able to print. But
Wait a
yeah,
minute, is this
cool.
the bot that's been sitting on that came with us? That came through Earth?
Yeah, this is the one that did I message you guys the picture of it sitting in my passenger seat? I had its seatbelt like buckled up. It's like, check
No,
out my
I didn't
co-pilot,
see
you guys.
No,
Remember that one?
no one was that. You don't think you sent it to us?
Oh, that's
I
funny.
think you
got
sent
the
it-
picture. I'll show it to you.
I think you sent it to the cult.
Oh, that's what I did. Yeah.
Yeah, you sent it to the cult.
That's funny. But it was just like I ran out of storage room, and I was like, where do I put this? It's my baby. Oh, there's a whole seat. Like, I'll just sit on the seat and buckle it in.
So Chris Riley wants to do it with you. He says
That'd
it'd
be
be
fun.
really sweet. We can try to resource the part. We can all try to source the parts.
Okay, so trolling for dollars. This is the fun part of this. The bed size is... Okay, so here's the thing. In its current iteration, what I have is a 200 by 150 by 200 build volume, 150 in Y. However, you could get a full 200 in Y. All you have to do is just make one little sacrifice and make not all of the linear rails exactly the same. And it just bugs me because I want to make all the parts exactly the same. But you could just make the cantilever 50 millimeters longer, and then you get a full 200 millimeter cube build volume. So that works out. But, also, I should say, there's another version of this in the works that's higher performance. This is like Core XYT, and it'll be fast, but not like lightning fast. I'll also be working on a version of this that is a full Core XY cube, and it is gonna kick. Beep. It's gonna be so fast. I'm gonna have to make a couple sacrifices as far as the coalescing the part types. It's gonna have a couple more types of parts, just because things need to be a little more specialized, but it'll be extremely high performance. Yes, that's right, trolling for dollars. 250 millimeters cubed. I would start worrying about a single Z screw. One thing I've been thinking about doing is dual Z screws in the back. So this is a nifty trick. And if you're using like a duet board, this is easy. And if you have a probe on it, it's easy. So you can go to the back and you can level the two sides independently. That means there's only one thumb screw you would have to adjust, and that's the front center. So it could be like a partly automated leveling process where it goes to the back and it trams itself in one axis, and then it moves to the front, and then it lets you just tram the rest.
Well,
So,
at least I'd be a little bit ahead. I do happen to have one part for it. Let me just pull this up.
That'll be
here.
part of it.
So I'm
The
already
other
ahead of the
option
game. I've
that I
already
really
sourced
like
a
is,
V6 E3D V6 here. So
Yeah, Chris Riley, you know what? I'd love to have you on board with this. It's such a cool little printer, kind of odd, you know.
If you need a
not really
beta
like anything
tester.
that's out there. I'll send you some of the parts and files. And let me know what you think. Yeah, I've been working on it for over a year. First renders were shown at Murph last summer. Yeah, it was a very interesting process. All fully laid out in CAD before I even had the printed parts started, just trying to fit the parts in space and see where I could make printed parts to just kind of glue everything together. Yeah.
yeah, 'cause I have this piece also, which I haven't
Yeah,
even
you have
used
a lot
yet.
of parts.
Yeah,
that you
this
use
was given to me from TH3D. This is their this I actually paid out of my own pocket. This is the Isabel, or the Easy bed leveler that they made.
Nice.
I still have to attach that to my printer, and I also have their Easy Out. This is just a sensor to detect filament, run out sensor. Yeah, like I said, I got a lot of parts. I just haven't had the time to put them into the printer yet because I've been dealing with everything, been piled up on top of while I'm trying to grow this channel and make it popular. Actually, how many of you people have how did you guys find out about the channel? Well, just curious. Like, was it just by luck, or was it just because I brought Daniel, everybody's now smarter and learns more that way? I'm not sure how I grew this channel up, but if you guys want to leave comments below, you're more than welcome. I'd like to read them. We'd like to, also emails, you can send them over to CMP Canadian Maker Project at gmail.com. I will receive those emails, and we can read them online and have some talk. If anything comes to mind that when Daniel's not here, we can cover it. But go ahead, Daniel. I know you're typing up some information there.
Yep, I'm just putting some stuff in the chat there for people. Yeah, Murph videos. That was the thing too. Apocalypse Survivor. So yeah, Ron came over at Murph and was chatting me up there. That was how I first found out about his channel.
Yeah, and I
Watched
interviewed
a couple videos. I'm like, this is fun.
and then Jacob came on with. Well, I had Jacob on when I was at Murph because I don't think you were around at the time.
Yep. Yeah, I was gone that time. You did a really nice interview with him, by the way. That was a really good interview with Jacob Ayers.
Well, I just want to get some idea of one part of Art 3, because I didn't really want to have the whole what's the word I'm looking for? Didn't need everybody involved, but I couldn't do it on Saturday because Saturday was just a madhouse. As you remember, Saturday was just insane.
Right.
It's had the guys from E3 come down, talk with you guys on Saturday, and
Yeah, they were looking at our machine. I had a bad feeling on Saturday. Everybody's machines were just malfunctioning, and
oh, at Earth, yeah.
yeah, at Earth, yeah, at Earth, at Murph, sorry. Yeah, Sanjay came over, and Jacob and I were sitting on top of our machine. That was funny. I have a picture of that somewhere.
Yeah.
But, yeah, we were sitting on top of the machine, just resting our legs,
Just
kinda
dangling
people
there.
watching.
Yep. There's a video, I think, of you playing the playing the fiddle.
Yep, yeah, the Hoveline that Chris Boleski printed. That was pretty fun. I was sitting on top of it playing there. Yeah, Sanjay came over and we did a shot with him. That was fun.
Yeah, I remember you guys were talking to Sanjay, and it's just like Barrett was like all intrigued with the conversation. He's like, "Oh man, and this and that and this." I'm like, "Okay, well, yeah."
Sanjay's a smart dude. I love talking with him. He makes everybody feel at home. Just a fun guy to talk with. He's got something to relate to everybody. Very, very much a people person. I really like him and his work and what he's been doing for 3D printing. Chris Riley, what did Sanjay have to say? Just asking general questions about like our machine and the servo motors we're using and what we did for tool changing, and talking about his tool changer, which I'm a big fan of. I like what he's doing with tool changing. In a lot of ways, there's a lot of parallel evolution. E3D, his team, and Art3, my team, did a pretty similar route. We both looked into kinematic couplings to pick up and drop off the tools with, very consistent locating, with the rest being done in tool offsets.
Hey, Daniel, there's a picture I found on your timeline here from looking at your stuff back in March 28th that shows you and Jacob with the printer. Do you mind if I pop that up on the screen?
Yeah, go ahead and put that up.
Okay,
Let's
guys.
see what people think.
So this is off of his Facebook channel, so I'm just warning you that this is off of his Facebook. So let me just get in a second here so I can pull that up. That picture right there.
Yeah, that's it. Oh, that's such a good story. So here, can you fix so that people can look at that? Oh, that's just one of my feature photos. It's me and my...
Yeah, sorry about that. I'm just going through
There's
that.
me giving a 3D printing class.
There it is.
There it is. So what that picture is at Murph, Jacob and Grant and I, we hauled like 7 loads of printer gear up from the U-Haul van up to our hotel room to build this thing overnight, like just to finish it, the night before Saturday at Murph. We were there Friday and chatted with people. It was not done, not ready. And Friday night and wee hours of the morning, we were printing pieces for this, configuring firmware, wiring stuff up like in the hotel room, just in a caffeine-fueled haze. It was a blast, man. It reminds me of the old days of like robotics competitions and stuff. But it was so much fun that last-minute panic set in. We're just like, but having a good time too, building this thing. We ended up not getting it working in time, but what we did was kind of prettied up. We pulled all the extraneous wires out, polished some bits up, put all the components in place, and it looked so good. It looked excellent. And we wheeled that thing into Murph. And I remember the reactions of people as we were wheeling it in, because it's got its own casters on the bottom, which is handy because it weighs like 250 pounds. There's no way we could lift it on its own. So we're shoving this thing in, bumping over extension cords on the rugs. You guys at Murph remember how that was. And heads are turning, like, people would look and just be like, oh, somebody's pushing through the crowd. I better, wait, what? What? What is this thing? It's the size of a fridge. Like, what are they pushing in here? And they look at it like, that's a printer? What the hell?
Yeah, I remember it was you and you, Jacob, and Grant were rolling it on in and going, move out of the way, printer coming through. And everybody's like, what?
Not going to lie,
Huh?
we felt a little bit smug rolling that thing in there. It was pretty cool.
Yeah, you guys did it again. At Earth.
Yep. We did it again at Earth. We rolled that thing in there. Well, we had it there from the get-go. A lot more wires in it this time, though.
Yeah, but it was funny because it didn't
was
come in
late
on
night.
the Friday. It came in on the Saturday.
Yep.
You guys are always a day late.
Yep. Yeah.
Let's hope this year.
Always
Do you hope
scrambling.
to get there on Friday this year, or?
We'll see. We'll see. I mean, technically, we did get the Friday. It was just like Friday at like 11 p.m. after loadout time.
Yeah.
Yeah, it was a long drive, man. It was like 9 hours plus. For me, it's like losing a time zone. So.
Yeah, because you got the because you got the East Coast, and you got the. Wait a minute, is Indiana Central?
Actually, that might be Eastern time. Yeah.
I think they were still in Central, Eastern. Yeah.
Yeah, I'm Central. That's Eastern. So. Yeah. For me, it was a 9-hour drive to Indiana. Well, more like 10 in the van because it's kind of slow. And then it was another 10-hour drive from there to Maryland, and then 10 hours back and 10 hours back. I drove like a couple thousand miles in that month when I was down in Indiana, but it was so much fun. We did so much cool stuff.
Yeah, crashing out. Yeah, no sleep. Probably a
no
bunch
sleep.
of non-sleepless
I
nights.
ran myself a little too hard. I got kind of worn out, but man, it was fun.
Well, at least you can crash at Jacob's place again.
Yeah, Zimmy is correct. It is Eastern time.
Yeah. I just remember that machine. We're watching it roll in and just going like, and I remember Barrett going, "Oh, you gotta come!" I'm like, "Okay."
Okay.
And he brings in and I see this big block coming through. I'm like going, "What the?" He's like, "Yeah, come meet the Colts." It's like, okay.
Yeah. That was fun.
Here's
having to
another
get
one.
All these people I knew online. Yeah.
Here is the one that you were talking about. Yeah, let's see if I can pull this up. Let's see here. Share screen. Share. There we go.
Oh yeah. That was the E3D team standing around.
Yeah, and they're
printer.
just looking at your printer, just staring at it.
Yeah. Couple things. So one of the thoughts I was thinking they might be thinking is like, holy crap, this thing is insane. And then the other thing is like, oh man, I wanted to see this moving, but it's not moving.
They also have this look
Yeah.
of we got to buy the company.
Yeah. Well, yeah, we're in a different bracket than them. I mean, they're working with, desktop. We're a bit more on the industrial side, but yeah, I really wanted to show them its movement speeds. It's just ridiculously fast. I mean, with those DEVA 23 scale drop-in servos, that thing is just scary. It can cross that build volume in faster than a human's reaction time. I mean, if you had your hand in there, you wouldn't be able to get it out in time. It's 1.5 meters per second top speed. It's really trucking. So, yeah, the safety panels that we put on there are for your safety, not the machines. But yeah, I really was hoping to have it zipping around and doing G-code and stuff for them, but we were having some issues with the motors. We're getting a better power supply for it, and a whole bunch of other little tweaks that I'm doing to make sure that the motors are consistent. Because servo motors like that are not really quite intended to be driven off of.
Oh, there it
Yeah.
is.
Got another picture to show?
Yeah, from Bethany Lutheran College.
Yeah, that's right.
Tagged the picture that you were in. Let's just see if I can. I can't pull the picture up, but it has me there smiling. I got caught in the picture somehow.
What's this one?
If I click on it, it might. Let me just show you. Okay, let me go into screenshots. There, share. I'll click on my screen.
Ah, yeah, that one.
Yeah,
So
I
that
like.
was the other thing.
Like there I am right there, which we can tell by the Canadian hat.
Yeah.
There's the bear, and there's everyone around it.
My
But if I
college
click
ran
on
a
that
little
picture, it's
article
just
about
going.
me.
Oh, it's an article
They
about
used
you.
one of the pictures that we had taken. I think that might have been off my dad's phone at Murph. Yeah.
Oh, there
So,
you
you
go.
guys can look at that article. That's where I went to school. Really nice program, engineering program just started up, and actually I'm the first graduating class
I don't know who that is, but
That's me.
that's you.
That's me. Yep, doing
What's the
a
large of
maker
this
meet
picture?
and greet at Barnes & Noble.
Ah.
Got my scraper and my hairspray. Yeah. That was last summer. That was quite a while ago.
Yeah, there's the.
Hey, Red Light 34.
There you are
Yeah, there's that
at
picture.
Murph. There's Barrett, the overhead.
There's Chris Pulaski. Yeah,
Yep.
The Earth
I
coordinator.
don't know who those two are.
I think that's Grant. No, no, that's somebody else. They might have been just people coming watching.
Okay. Yeah, because I was surprised how much you knew Chris really well. Because all of a sudden Chris is like, "Yeah, don't worry, we know."
Yep.
I remember going, yeah, Daniel's running late. They pulled in at 4:00 in the morning. He's like, "Yeah, I know. They messaged me to warn me that they're going to be late getting in."
Yeah. Yeah, I chat with Chris from time to time. He's a great
Oh,
guy.
that's
I like him.
interesting. Didn't know you took this picture. Show this
Which
off
picture?
again. Sure. This one right here. The 360.
Oh, yeah, yeah. Was that sitting on top? That might have been from sitting on top of our machine.
Yeah, now it's not even allowing me to do the. There we go.
See if you can pan around that. That was a fun panorama. To take.
Yeah, I'm waiting for it to load up here. It's being buggy. Come on. There we go.
I took that picture to show people like what Murph is like.
Yeah.
Yeah, that was the view from on top of our machine. Yeah, I was sitting on top of the printer when I took that one, I think.
Let's see if we can find me in this madhouse of madness.
You're probably over to the right.
Yeah, probably.
Yeah. Ooh, Red Light 34's got a question.
Oh, there's Glenn. We found Glenn. With the Fun King 3D logo on the back.
Oh, yeah. There he is.
There's
I
Glenn.
didn't know him then, but
Yep.
that's him. And there's my dad.
Your dad?
front.
Whereabouts?
Keep scrolling right.
All right. Come on.
It's loading. Or other way, I mean. Like left in that case. Like go to the right of the picture.
That's as far as it's letting me go.
Oh.
Ah, this stupid mouse.
There we go. Yeah, there's my dad down in front.
Oh, okay.
I think you should be able to scroll even a little more. Yeah, there we go. Hey, there's our booth. There's Jacob. You can see a little bit of Jacob.
Yep.
Yep, and you can see all the way down into the other room. You can even see a little bit of Part Daddy if you look really closely.
Yeah, right
Murph is
there.
definitely a rush. It's surreal. Like there's just so much printing going on. I love it. So back to Red Light 34's question. Do you need the nozzle insulation, like the cotton or glass wool or whatever that is? No, you don't need it. But especially if you've got forced air running around the nozzle, it does help with temperature stability, and it does help keep the heat in, so there's a little bit less drag on the heater cartridge. So it's helpful, but not like strictly necessary. So generally, like that would be the last thing I add on a printer. Honestly, none of my printers have it on right now. But if you're just like working on making a printer as good as you can, that would be like one of the very last things I would add. Once it's all put together and all tuned in, and yeah, then I would add the cotton and then do one more pid tune. Hey, there we are. That picture there is pretty good of us sitting on top of the printer, me looking all dorky.
Yeah, I'm just going to be showing that on the big screen here. There we go.
Yeah.
Hopefully you guys can see that. Yeah, that's them being on the printer. That was an interesting tweet.
Yep.
There I
I'm
am
glad
right
that,
there.
You know, machine nerds are liking it.
Yep.
Okay.
And there's
yeah,
me
Red Light
with-
34. You'll be okay without it on the CR10. The airflow isn't like too crazy. As long as you do a PID tune, you know, you'll be fine. Yeah, a silicone sock is easier than like a cotton wool thing. A silicone sock is much easier to slip on and off and deal with. Yeah.
There's an idea, guys, of what they were
there
doing.
we are. This here is us in the us in the hotel room working on stuff. This is probably taken at like what 2 a.m. or something.
Yeah, there's no timeline that they put on this. Yeah, but probably.
Yep.
Yeah, so that's the machine that they were talking about. I was hearing so much talk about this aluminum monster.
That's the one. Yeah, look at the printers spread all over.
Did you guys actually go to bed that night?
Nope, I didn't.
Nope.
Actually, I shouldn't say I totally didn't. I had like a 30-minute nap in there somewhere, but
Yeah, yeah, machine porn basically is the best way to put it.
Eric Cederberg is very knowledgeable.
Yeah, so go back. I'm going to cancel this out now. But yeah, I just wanted to show some of those pictures because I thought some of them were pretty impressive. So I'm going to catch up on the chat.
Sure.
Ron's sending you more Murph on Twitter. Okay, let me go look at Twitter. Well, okay. Let's put it this way. I'm looking at buying a printer right now. I'm at that point where it's like, do I go Delta or would you not recommend Delta? What's your thoughts on Deltas?
Okay, I have mixed thoughts. So okay, it's always a question of matching, the amount of money you want to dump into the project to the architecture to the use. You can make any printer work for any use. It's just a matter of like how much money you have to dump into it. So, what's the use case for this printer that makes you consider a Delta? Like, what type of stuff are you going to be printing on it? What's your size range? What's your speed range? And about how much are you looking to spend?
I guess the one I was looking at was $199. It got some good reviews. It's the HE 3D. I'm trying to remember the model. I think it's K200, which is I saw it at a good price. I saw it for $199. It's a 300 by 200 bill. The bill plate's 200 by with a 300 height.
Yep, I see the one. Looking at it now. Yeah, that's pretty cheap. That is shockingly cheap. Okay, I see some things I like about this. It's got some things on it that are good. This one, that's right, I looked at it. Yeah, the wheels, the V-slot. Is it true V-slot? I think so, that'll be good. It is running on an 8-bit board, which is to be expected at this price range. So it will be limited, but it's okay. It's not going to be like a total performance monster, but I mean at this price bracket nothing is, so that's fine. You might want to make minor updates here and there. It looks like the end effector could be improved. I've got something I could send your way, a one-piece printed end effector that's very light, has integrated cooling, minimal part count, extremely stiff.
Yeah, when I was looking at it, it caught my eye because a couple of people were saying it. It takes a little while to build, but it works really well. And that's what I was hearing. Like everybody just going, it works well, so it's worth getting. So I was like, I don't know.
With this printer here, this might be a good candidate for a silent printer. If you wanted a silent one, I could send you a list of the mods. Heck, we could do a whole stream about that if you wanted. How to make one of these Deltas just totally like freaking silent.
That'll be interesting.
You can do it. You just got to go through, just like like I was saying, chase down the bottlenecks. You got to chase through the noise sources, just eliminate them one by one. And it doesn't make sense making something totally noiseless if something else is going to be making a lot of noise. You got to work with all the noise sources and bring them down by, the same amount.
Yeah, that makes sense. I mean, especially when you want to do that.
Yep.
But I was thinking just as a candidate printer for printing out like do 2020 extrusions, do my 4040 extrusions if I need to, if I want to go all print based and build a printed printer,
Yeah, go for it. This looks like a pretty good printer for the price. I would do that. I would do a couple things though. I would reflash it with your own firmware. Not use the screen. Using a screen, a graphics controller like that takes a surprising amount of core time. And that can slow down your prints because your cores are going to have a tough time calculating all those, floating point calculations, which, since a ATmega 2560 doesn't have a dedicated FPU floating point unit to do those calculations. It's got to do them with long series of adds and subtracts, which makes, for some pretty slow calculations sometimes. Yeah. So to get all those segments done, it would probably be a good idea. You can make it faster and quieter if you get rid of that screen. I can give you a custom firmware build.
Yeah. Or just put a ramps board in there and have your own ramps running, I would think would probably be your best bet.
Well, the board looks like basically a derivative of ramps. So electrically, it'll be basically the same. You just drop in some different drivers, silence it, and you can do some nifty tricks.
Yeah, we could do that. I use the, was it TL Smoothers, I think it is, what quiets it down?
I wouldn't do those. What I would do is TMC 2100s or 2130s.
Okay.
They don't have the most power. But in Stealth Chop, the really low torque one, there is a way to use that on a printer. The nifty thing is that when changing direction instantaneously or stopping and starting instantaneously, they actually do send a pretty sizable slam of amperage just for that quick millisecond.
Yeah, I'll be right back. I gotta go check on some filament that just finished drying. Hang on.
All right, sounds good. I'll keep people.
Good old use of a timer.
Yeah.
Walter is planning on upgrading his Delta. I know he's planning on doing that. He's going all to, I believe he's using Duet driver. He's using Duet board. But you know what? I just can't justify buying a TiVo Little Monster after seeing the monster that it's become for him.
Yeah. A TiVo Little Monster is mechanically interesting. Has the potential to be very rigid and very reliable, but there are just a couple things they dropped the ball on. And yeah, a Duet makes it so much better. So much better. Duets are really good for deltas. With that 32-bit processor and the dedicated FPU in there, they can crunch those numbers and have lots of core time to spare. I mean, they're not breaking a sweat. So that works great for that. However, if you're sticking to a budget build and you're running a 2560, an 8-bit board, then you gotta work on minimizing your the stuff that you're computing, because you want to save core time for the necessary kinematic calculations. Yeah, Chris Riley, TL smoothers are a band-aid. I know what you mean. 2100 TMC 2100 drivers and stuff in the TMC, the Trinamic drivers, is a whole different class. They're made to be very sinusoidal right out of the gate. They're great on their own. TL smoothers are a weird, non-linear voltage effect diode band-aid that you stick on top of DRV 8825 drivers in mixed decay mode to fix one of their voltage things. It's like undistorting a distorted decay. Yeah, I'm going to stay out of that. I would prefer to stick with like good, nice sinusoidal drivers, like the 20 something series TMC drivers.
Well, you made a friend out of Chris Riley. He's like, I'm so glad someone said 22XX versus TL smoothers.
Yep. Yeah. So just talking about. Yeah. So another thing for these deltas that I was mentioning is, so the thing about stealth chop mode on TMC 2100 drivers and like Stealth Chop 2 and the other upgraded versions is what they do is they say they're velocity compensated. What that means is at higher velocities, where stepper drivers and stepper motors typically make more noise, they taper off the current. Now, that's great. It prevents the noise, but the problem is often at high speeds and stepper motors already experience a torque fall off at higher speeds due to the way the magnetic fields work. You need those high currents if you're going to be doing acceleration at those high speeds. So high accelerations really don't work well with those drivers in Stealth Chop. you have to have the accelerations very low, so the forces are very low. And you might say to yourself, oh, well, that's stupid. Now your prints are going to be just like terribly slow. If your accelerations are slow, that means you're going to take forever getting up to and down from your target speed. What's even the point of a delta then? Well, here's a trick, and it's kind of a hack, but what you can do is you can set the jerk speed to be super high, higher than your movement speed. Quick thing. Thanks for stopping in, Red Light. Yeah, you too, Zimmy 1958. I'm so glad you guys are all here. I have a fun time talking about all this stuff. Thanks for tuning in to the stream with Ron and me.
Yeah, I don't know why it's locked on me all of a sudden, but the camera just did.
Okay. Back to the stepper drivers. So if you have your jerk speed, so your absolute, or maximum instantaneous velocity change set really high, like on my lightweight delta, I had it set to 64 millimeters per second. Any speed below that, it'll instantaneously change speed. And what that means is the drivers will sense that, freak out, and send one slam of current to get it moving at the right speed. But it's silent because that's such a short interval. The driver's still very quiet. So the accelerations are super low, but the jerk is like ridiculously high. Now, the flip side of that is you're going to have a lot of ringing, like just a ridiculous amount of ringing, unless you are very careful in your machine design and everything is really tight and rigid. So that's the flip side of that. You can make a delta totally silent. It's just that it's going to be like banging and ringing unless you make everything really, really, really light and really, really rigid. So.
Yeah,
Ron,
it seems like Red Light wants.
Filament you're drying.
Yeah, so just tried a roll of eSun PLA Plus, which you guys will see in the video how bad it was. It was just, you touch it, it snapped. It was horrible.
Really brittle, huh?
I don't know what got in. I've always had a problem with this eSun PLA. I can never get it to print right. Everybody recommends at least 220 to 230 for this PLA. Because it is the PLA Plus. It's not the standard PLA.
Right. It's a higher temp, higher viscosity, higher strength, higher chain length.
Yeah.
PLA resin.
And for some strange reason, it has almost like a glossy finish whenever I print with this stuff.
That's
Not flat.
all right, if that's what you're expecting.
No, I'm not expecting glossy. I was just expecting a good black. And it tends to be a very glossy black.
Yeah.
I don't know why it doesn't look glossy in the packaging, but apparently it is.
Well, sometimes some of that has to do with like the nozzle. As it's heated up and melted and squished out, that kind of smooths the surface of the filament.
Does drying help? Yes. Drying does help.
That's good.
Well, no, Chris was saying, does drying help? I'm like, yeah, it does. Whenever I have filament that's not cooperating, I find drying's the best thing you can do. So.
Yep. In general, that's just a good rule of thumb. Having print issues, just throw that filament in the dryer while you're working on, resolving it. Dry filament never hurts ever. It never hurts to have dry filament. Just keep it dry. Dry your polymers. The polymer industry is so big on that. So big. Whenever you're melt processing a polymer, dry it. It's a multi-billion-dollar industry.
Send me, I'll get it to print.
Yeah, you got to give these guys a dehydrated video.
Yeah, I know. Okay, guys, it's done. I got the video done. I just got to edit and put it together, but I was dealing with another issue, which I'm trying to trace down what's causing this. And
let's dive into that tonight.
Yeah, so here's well, let me grab both of them. Give me a moment. Just so you guys get an idea of what we're looking at.
How y'all doing tonight? Just waiting for Ron to get back. Hey, there he is.
The yellow,
He's
my
back.
my orange PLA was brittle, okay? But I want to show you what also it was doing because of it being wet. In print, it would lift off. Like, look at that. It didn't even
Yeah,
seal
bad
it.
delamination.
That is because the filament was wet when it was printing on it.
Did you
And I
see
would
that,
have all these
that
little
popping
weird
out of the
holes.
nozzle
Yeah,
it
and look at
sticks
that.
itself and, yeah.
Look at that. And sometimes it'll be there and sometimes it'll just disappear on the other print. Like, right here is the second print, and as you can see, some of it did not match, some of it popped. And right here you can see it's pulling apart.
Yeah, nasty stuff.
This was when it was wet. It was doing horrible. Dried up, but look at it what it's still doing.
Better,
And I don't know if this is why it's doing this on the orange filament.
better, but there's definitely more in there. There's something
Yeah.
else going on.
Okay, I don't know what the heck is going on, but I'm getting a lot of beeping from Discord. Give me a moment here.
All right.
Someone's jumping in and out of Discord. I was just getting it every 5 seconds. Sorry. But yeah, it still was, that was bad. And that's when I found out water was dripping off of the nozzle. Like you could see the little bubbles and I could hear it
You see
boiling.
the steam? Holy crap.
Huh?
That's just awful.
Yeah, so that's why I had to dry, and that's when I figured out I got wet filament. Damn.
Yep.
So then I went and reprinted this again last night. This took about 7 hours. And as you can see, it is a lot better in areas. But in other areas, it just went.
Yeah, I would
Weird.
still call that unacceptable. There's something else going on in there.
Yeah, so, and it's only with this filament I'm getting it with. So that's kind of weird.
Really? Okay, well, let's take a look at some things. Let's run through, my mental list of troubleshooting stuff. Number one, let's look at those retraction settings again.
Yeah, the retraction settings are non-existent.
Yep. Yeah, Kira, did it get an update or something? That's
I don't know. I can't see them anymore in the Cura software.
So
Let me,
you must have to enable them under like the
let me
settings
open up
as
Cura
well.
for you guys so you guys can see what I'm doing here. Let me open up Cura. There it is. Share. Full screen. There we go. So as you can see here, here's the quality. 2 layer height. Wall line thickness 0.45, bottom 0.45. Wall thickness, top layers, infill density, triangles, gradual step. Enable retractions just has a check mark in it. I don't know if there's supposed to be more to that, but let's have a look.
Yes, there should be. Look under that material.
Retraction at layer height.
There's
Turn that
more. There you go. Retraction distance and retraction speed. That's what you're looking for.
Okay, do we want to also turn on these two, the retraction prime speed and the retraction speed?
No need really, but yeah.
How about retraction extra prime account?
Generally that should be 0.
Okay.
So
Oh, yeah, let's look at this now. We'll go close.
honestly, I
Boom.
don't get as good of results with Simplify 3D as I do with Slice 3R. Its control over extrusion widths gives you some really advanced capabilities that Simplify 3D doesn't have.
Okay. I don't have simplified 3D, unfortunately.
Yeah, I think you can get good results in any slicer as long as it's properly tuned. Yeah.
Okay, so looking at this right now, our retraction layer, retract at layer change is check marked. Retraction distance is 4.5 millimeters, and retraction speed is at 50 millimeters per slash second.
Okay, those should be fine. Those should be fine. I'm wondering about the CR10 itself. If you were to go over that and check its settings,
Yeah, just
I wonder
let me
if it's
go. Let me just
set
go over
right.
to that machine and pull that up for you. Stop it. But
Yes, Slice 3R for the way
you know, if you want to go into a little bit of what we were discussing for the for talk show, I was looking at doing a interview based show, guys. Chris Riley, would you like to be interviewed? Just thought I would throw that out there since you're in the chat right now. thought I would throw that out towards you, where it'll be just me and Daniel will be interviewing you specifically. No, just an idea of a show I'm working on right now. So I thought I would throw that out to you. I'll be back in a second.
All right. Let's see. Where were we? So I've got a couple things that I have a hunch on for this printer issue. One, and the first thing I would always look into is if the retraction is too long, what it might do is pull the melt blob up into the cold end and it'll freeze there. If it does, it'll stick and it's not going to be easy to come back down again, which could lead to skipping, and that'll lead to the behavior that you're seeing here. Another thing might be a partial clog. It's just popping up from time to time. I'll have him check for that. Maybe we'll do a purge, maybe a cold pull. Another thing we might want to do is check the stepper driver reference voltage. Yeah. So just a bunch of things we tend to go through, all in the extrusion system. You're just trying to troubleshoot every step of the line, from when the signal is sent to all of the electromechanical systems it's sent through, the wires, the motor, the extruder drive gear, the bearing, the Bowden couplings, the fittings, and the tube, down to the heat break, the nozzle itself. Is there clogging there? If any part of that is not functioning as intended, you might get intermittent extrusion like this. So you just kind of go down the line and you check. Some things are more common than others. Some manifest a little differently than others, and you just kind of learn that by experience. So, as long as you get through all of them, that's what really matters. But to save time, there are some things you can tend to look into first, depending on how it looks like. So, depends. Yeah, I've been using Slice 3R ever since I got into 3D printing, pretty much. This is kind of a funny story. So, the printer bot Simple Metal, by the way, rest in peace, printer bot. Miss you guys. That's what got me into printing. That printer is, well, I still
sorry,
have
Daniel,
it.
I forgot to leave it on you.
Yep. Oh, Chris Riley has, on printers like CR10, I see a lot of issues with pneumatic fittings, both to slipping or retraction. Yes, that is a big thing. That happens a lot with cheap pneumatic fittings. Often you'll print like a Bowden keeper, so to speak, that kind of jams that fitting up to make sure that stays locked.
Okay, Daniel, I just sent you the. Sorry, yeah, I just sent you the picture right now. Check your Facebook.
Checking it out.
Okay, I'm gonna be back in 1 second. I just gotta use the washroom though. Ugh.
Here we go.
I'll send the other two while I'm at it.
Okay. All right. Some of these numbers are looking good. Yep. Yep. Trying to look at all the settings on the CR10, see if something's set wrong. Let's see, where are we? Oh yeah. Anyway, PrinterBot Simple Metal. That's what got me into printing. I bought it because there's a promise of a driver for Windows 8. Remember that, guys? Back in 2014. And you could just run it from Windows like a normal printer driver. I didn't think I was up to using a real slicer, so I was like, I don't know, maybe I can handle this. Well, I bought it and I used that built-in slicer for a week. And it got me going, but then I realized I needed more control, so I downloaded Repetier Host and tried all the built-in slicer plugins. And Slice 3R was the one that clicked with me the most. Just the number of settings it had. I was like, control, yes, I can do stuff with this. Now I have room to tweak. I used that for the next 3 years, just learning all those settings inside and out, and then moving on to other slicers and learning their settings inside and out. And I keep coming back to Slice 3R. It's the way it controls speeds and the way it controls extrusion widths, the way it separates profiles. So you've got your print settings, you've got your printers, and then you've got your filaments. And you can swap and mix and match between all of them without affecting the other settings. I love it. I love its organizational scheme. I love the features it has. I love Slice 3i. Makes a lot of sense for me. So, yeah, the Swiss-plated anti-wear nozzle on it. Yeah, red light. That's a good thing. Those like nickel-plated nozzles or whatever anti-wear. I forget what the mixture they put on it is. It might have like PTFE in it or something too. But yeah, the wear resistance, it's good. But keep in mind, if you're working with stuff that has particles that are like thicker than the coating, they could still scratch through it eventually. So it's anti-wear, but it's not like hardened through and through, right? Like a true hardened steel nozzle is. So it's a nice middle ground because it gives you some wear resistance up front, but the same like thermal conductivity of a like a brass nozzle. However, if you stick a hardened steel nozzle up in there, you might have to increase temps by a couple degrees. Not that big of a deal, really. Often you're fine leaving them the same. But it will have wear resistance through its entire life, and not just like at first. I've seen some plated nozzles that got worn through, and yeah, $20, no big deal. Yeah, this guy was running a lot of glow-in-the-dark filament, and it was funny. The prints looked great for quite a while. They did. They looked all the same. And it was like, yeah, the nozzle held up. But after a while, suddenly that coating was gone, and the nozzle blew out like that. I mean, all of a sudden the prints went to crap, and that glow-in-the-dark filament bored that nozzle out to like a 0.6. Once it got through the coating and got to the brass, it just it destroyed it. So, yeah, keep an eye on that.
Sorry about that, everybody.
All right, he's back.
I'm back. So let's talk about what I sent to you. If you want to pull up the screenshot and talk about the numbers that you're seeing.
Yeah, I see something here. Couple things. Vmax in E, it's still limited to 25 millimeters per second. You see that in the firmware?
No, you haven't brought that up, the picture yet.
Tell you what, yeah, I will share my screen.
Yeah, makes it easier. Then I can write down what we need to look at.
Here are the pictures that Ron just sent me. This is the first one, steps per millimeter, and all these look pretty good. Like that'll be the ballpark for that. That's correct. That's correct. That's correct. Let's look at acceleration maximums. That's pretty low, really low. That's all right. Vmax, that's too high, although it's not going to hit that anyway, so that's all right. That's pretty low. That is too low. 25 millimeters per second is too low of a maximum speed for E. That means any retraction you try and do above 25 millimeters per second is going to get capped to 25 millimeters per second. Now, one thing that means is your prints are going to take longer than your estimates are. The other thing is, yeah, if you try and do a nice snappy retraction, it doesn't matter. It's going to cap it at 25. So that could be one of the reasons that your prints are turning out the way they are. If that reverted back and your retractions are really slow like that, that might be part of it. Let's see what else we've got. Was that all?
That's all of it.
I think that's it. Yep.
So I would want to change that to what, though?
I would just change that to something high enough where you're not going to have an issue with that being the bottleneck. You're going to want to change that to something with some height, like headroom would be 75, 100 millimeters per second. Something you're not actually going to hit.
Okay. So 100 would
do it at 50 millimeters per second, like you're commanding it to.
Yeah. So try like me at 100.
Yes. Change it on the printer. Change the maximum to be 100. It's not going to hit that, but it'll allow it to do any speed up to that.
Well, let's see if my printer will accept it, because last time, remember, you were getting frustrated with that stupid printer. It wouldn't take it.
Yeah. Yeah. I mean, you could make the changes, but like anytime you did a power cycle, power off, power back on, they're gone. So,
yeah, but then I can always do the edit.
Yeah. So.
And write that down to change it to 100. Okay.
What are the jerk settings on it? I can't remember. I don't think you included those here, but I do remember they
If
were
I
too
did
high.
include a jerk picture. Did I?
Yeah.
Not?
I didn't see that.
If I didn't, I can provide that to you right now.
Yeah.
Let me have a look.
Okay, yeah, you didn't post that.
Oh, I didn't. Okay, wide jerk. Here we go.
Let's see what numbers you're looking at.
Share that with Messenger.
All right. Thanks
There you
for
go.
tuning in, trolling for dollars.
Yeah, $1,200. You're heading off. We're not going to be on much longer, but like I said, this is going to stay up. So if you want to review any of the information that we talked about, you can totally go back and check that out.
Okay, here we go. Oh yeah, these settings here. Acceleration is just 500, but XY jerk is 20.
Yeah, you might want to bring that up on the screen.
Yeah, I will bring that up on the screen. Oops, not that one. Here we go. This here, 500 millimeters per second squared is really low for acceleration. There's not much force being generated there. Versus an XY jerk speed of 20 millimeters per second, it's changing from 0 to 20 and back again instantaneously. That's a lot of force. So what this means is it's front loading your forces like all in the very beginning of the move, and the rest of it has like none. That's not good. You should increase this. I think we had that set up to 1,000, and this set down to 10.
Okay, so
All right.
1,010.
So double this and have that.
1,000 AC. And the XY jerk to 10.
Mm-hmm.
And what about changing anything on? I'm just opening up my pictures here so I can follow along here.
And then this one, the Vmax of E is the other main one you're going to change.
Okay.
Vmax of E has to be higher. Change that to like 75 or 100.
Okay, so I'll type that. Okay, so VMAXE.
Mm-hmm.
Yeah. Okay. To 100. Yeah, I got that written down right here on a
Good.
piece of paper. So.
Yep.
Now, when I'm doing a now I'm going to bring you on definitely when I'm ready to do the upgrade to the printer itself, because I have a feeling there's a problem with the firmware, which me and you have both discussed could be causing the issue with it not saving the settings once we finish programming them in the printer.
EEPROM is probably not enabled like persistently. Yeah, it's not working. So.
Yeah, so when we get to the point that we're doing the when we get to the point when we're ready to edit the machine, I'm definitely going to have it here, the box here, disconnected and plugged into the computer so that we can go in and re-update the firmware. And I will do the firmware update first, and then we'll go through the firmware that TH3D has done, and we'll look through the firmware and see if we can edit it directly through firmware. Can you edit the firmware to accept that changes?
Yes. Yeah.
In the
I can do
firmware?
that. Yeah, I can adjust that in the firmware.
Okay, then we'll go through that, and we'll go through everything, and
Probably
then
has it set that way. But yeah.
well, hopefully he has it set. If not, then we can always edit the firmware to have that information. Then I can actually add on all the extra parts I have right here. These two pieces.
Yeah.
But
So,
I also got to send stuff back to Amazon because it sent me the wrong parts that I ordered. So, yeah, and it was on Prime Day too, of all things.
That's not good. No, they were
Well,
busy.
They said they sent me the router I ordered. They didn't specify it was N or AC. I figured, okay, it's probably N. If it's N, it's got to be 600 or higher. No, it's 300.
That's no good.
No, especially when my home router is 300 in the ceiling up here. So I'm
Yeah.
just going. Well, the only one router / cable modem I have. So I'm like going. So that's going back to Amazon. So once I send those stuff back to Amazon, I may pick up a couple of NEMA 17 motors so I can do that D-bot, because that D-bot is still interesting me to build.
Yeah. Well, you have the motors for that out of your
Yeah, but I want to get two NEMA 17s to control the bed up and down.
oh, the bed. Yeah.
Yeah,
Yeah,
you
you
want
could get
it
new
says
motors
that
for
you need
that.
two of them. So I don't want to put one NEMA 17 and use one of the Troxy motors, and we find out they're just slightly not right speed with each other.
Yeah.
So getting two of the exact same motors might be the best way from the same company. That way I can have it do it at the
Yep.
same time for the bed leveling.
Yep.
Now, when you're doing any type of, whenever we're putting like a ramps board or anything like that, do I need to change anything on the ramps board itself?
It depends on what you're setting it up for. I mean, on the ramps board,
Like, would there be like, okay, give you an idea.
jumpers and things.
No, like on a duet board, they come with a whole bunch of different designs. So you could be running a Core XY, you could be running a Delta, or you could be running a Gantry.
The
Like,
rep firmware configurator. Yeah.
yeah, is there anything I have to uninstall out of that or change?
Yeah, if you're setting up Marlin from scratch, you have a lot of changes to do. You have to enable a bunch of things and set that up. So it'll take a little while. But I can help you with that. No worry. I've been doing that for quite a while. So.
Yeah, because I'm going back into programming to learn all my programming languages and brush up on my programming. That's one thing I'm going back to school for. And then I found that the school I was looking at has a full-fledged makerspace.
Nice.
Yes, and also our libraries out here have laser cutters and full makerspaces also.
Laser cutters are sweet. Very useful.
Oh, I've never used a laser cutter in my life. I'm a little scared because I think I'm going to cut off a finger or something like that.
Yeah, well, you know what they say. Just like when you're doing electrical wiring in your house, don't poke around in the box with both hands. Use it with one hand tied behind your back, right? So if you do shock yourself, it doesn't go through your heart. Well, the joke about lasers is if you do lean over a laser cutter, do it with one eye shut, so you might have one left.
Yeah. One of my friends has a really funny joke, and this has to do all with being a when we were learning networking and learning how to build servers for networking, and he just says, "Yeah, if this school ever got fiber, all you do is you to open up the closet and you just see me petting fiber like a kitty cat, and we'll just go and it'll be like fiber, 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 and we'll be like, okay, close the door."
Close the door. Oh, that's funny.
When you think about us networking idiots, it's like fiber.
This fiber optic is the way to go.
I remember one day we were
Oh,
like
so
going.
pretty.
I remember one day I was talking to a teacher and it's like, this network is so unstable. I said, "Have you ever thought of giving it fiber for a steady diet?"
Yeah.
It's like that you just start
That's right.
crying
A
over
steady
laughing.
diet of fiber makes the network very nice.
Yes. Imagine if we get to the point that we have fiber for 3D printers.
Like fiber optics controlling the components, or
No, fiber optics are actually for cameras that would use the fiber optics to make sure that make sure everything is sticking to the bed.
advanced feedback. Yeah, that's tough stuff. That could be a whole stream in and of itself. I mean,
Yeah, I think we just went over
that's
everybody's
cool, but
head when I said
tough
that.
stuff. You just got the gears turning. I just went back to like 50 conversations I've had about this stuff. Oh gosh, that's nuts. That's nuts.
Yeah. Hey,
But-
question for you. Do you know the difference between build plate versus like Anycube's building surface that they're doing?
Anycubics. What is that?
Ultra base.
Ultra base is the name for it. Yeah. Honestly, I've never used one of those myself. I would love to stick that inside of like, what's the machine my buddy's got?
Spectrometer?
Yeah, infrared spectrometer. We can see what it's made of. But I don't know. I haven't gotten one yet. So.
Well, guys, if you want to donate any net build plate, you know the person to
Anycubic
talk to.
Ultra base or anything like that. Any fun build surfaces like that. I would love to test them. That would be so much fun.
I have Gecko Tech sitting upstairs. I have not installed on the CR10 yet.
Do ya? Oh, I hear good things about that.
Yeah, I got the Gecko Tech. I got their lifter that they recommend for it.
That's cool. That's very
Yep.
cool.
Oh,
That'll be nice.
all
That
new
300
toys to
millimeter square
test.
plate of Gecko Tech. That's nice.
Yeah.
It's a lot of plastic.
I can see you going, I'm a little jealous, just a little.
That's what you're seeing. I am a little jealous. Yeah, PEI.
Yeah.
PEI, man. So many people swear by PEI. What's the saying? Like, when you go PEI, you never go back. Yeah.
I don't know. Hard to say.
Well, do you want to keep looking at those retraction settings?
Well, that's about it. That, yeah, if you want to go through that a little bit more.
Sure, sure. Unless people have questions and stuff.
Yeah, if you guys got any questions, fire off away. I think that everybody's starting to fall asleep, but let's just put it this way, guys.
I
I'm going to
think
look
so.
at our channel here. Let's see, Nightbot. Let's go right into my analytics for tonight. YouTube. Do. Still at 120 subscribers.
Nice.
And we're sitting at 11 thumbs up.
Hey, that's good.
So they love you, Daniel. They love you.
Oh, I'm so flattered, you guys.
That's my video repeating on itself, if you guys heard that.
Yeah. Wow. John Mack says he's been on his first sheet of PEI for over a year. That's good. I can't say the same about any other surface I've used. I still haven't made the jump to PEI yet, but believe me, when I do, I'll probably just put it on all my printers. You know how it is. I'm dragging my feet because I'm kind of a what would you call it? Status quo. If it works, I tend
Why
not to
change?
change it. Yeah. If it ain't broke, don't fix it. I know I will make the jump to PEI eventually, and I'm sure it's going to be really nice when I do. I hear a lot of good things about it.
Well, let me ask you this. Like, what's your favorite build plate right now that you're using?
My favorite, really any surface as long as it's just got a very, very light dusting or wiping of hairspray.
So you're in the hairspray group, not like
I'm in the
glue
hairspray
or
group just weekly. I've been able to get a lot of good results with a lot of different things. Build tack, knockoff build tacks, glue stick, plain glass, various types of tapes, capped on hairspray. It all works. What I more pay attention to is your first layer offset and your temperatures. If you get those two right, you can make filament stick to a lot of different things. So,
imagine getting it stick to paper.
Oh yeah, you totally can. That's basically what tape is.
Well, no, I meant like
Just like plain printer paper, like white sheet. Yeah.
Yeah.
You could. You totally could.
It'd be interesting to take your paper and pop the print off of it.
Yeah. It'd probably be sacrificial. You think?
Yeah, probably.
Probably rip.
Yeah.
But
One thing I have been kind of interested in, and I don't know what your thoughts about it is that the mirrors you get from the store. Have you printed on mirror yet and given it a try?
yeah, I printed a little bit on mirrors, not on my personal machines, but on the machines I've worked with at other people's places, and some at Jacobs, and stuff like that.
What do you think of mirror?
I think mirror is good. So, one thing about glass production facilities, the glass they use in mirrors is like chemically exactly the same as window glass. The thing is, just like companies bin components differently, like electronic components, semiconductor components, based on how well they perform, they do tend a little bit to bin mirrors, mirror glass. So window pane glass, flatness matters, but it doesn't matter quite as much as it does with mirrors. They're all float glass. They're all chemically basically the same. It's just that mirrors being silvered on the back side show off distortions a little more. So they tend to make them out of glass that's produced a little more slowly, that has a little less internal stress and is a little bit flatter. You know, there's still some overlap. Like, not all mirrors are flatter than all window glass. You can get window glass that's great, and you can get mirrors that are crappy. It's just overall mirrors tend to be a little flatter sometimes. The other nice thing though is visibility. When you look in a mirror, you can immediately tell whether it's flat or not. You just wave it around and look at the reflections. You can see whether a mirror is distorted. If a sheet of glass, just plain straight glasses, it's harder to see the same level of distortion. So as you're picking up like sheets of glass in a store, like a hardware store, it is easier to tell if a piece of mirror glass is defective than it is to tell if a piece of like window pane glass is defective. You might buy a piece of window pane glass and get that cut and get that put on your printer and not realize it's got like a dish or a ripple or a bow in the middle. Whereas you would have been able to see that immediately on a mirror just because it's silvered and you can see the ripple in the reflection. So it makes it easier to tell in the store whether it's flat or not. That's my main thing. I like mirrors for that purpose. You can tell just like looking at them, just kind of make sure they're not, nothing funky going on.
Yeah. Next update I'm doing to my printer is I'm installing these.
LEDs, lighting. Good.
Yeah, because I figured, why not make the printer look pretty?
Yeah, makes it easier to see the parts too.
Yeah, so this stuff I picked up at one of the maker fairs in Toronto from a company called PC Board Lighting. Huh. And this guy swears he got like the best lighting, and this stuff is like super bright white.
Yeah,
that's it right there on the reel.
Very nice. I got
15 feet
for some of my printers. I haven't really done
$5
LED lighting yet. Been talking about it for like 3 years, but I just haven't done it yet. I know.
You still have 3 printers sitting on your ground that you haven't done yet.
I know.
What's going on with your forge? I noticed it's been sitting there not printing nothing.
Yeah, so man, I've got my printer bought. Still needs a board fixed for that. I've got my console midway through a complete overhaul, like from the ground up. I've got the new one that I'm working on, which is of course not quite finished. I've got the FT5, which is in pieces because we grabbed some parts off of that, like the cable chain and some of the wires for the big printer we're building. And I've got the big printer, which is still, got a lot of work left to do on that. So I've got all these printers and they're just not done.
For a guy that talks about printers, about the technology of them all, you'd think he would have 1 or 2 working.
Right? I know, right? It's like, and now I'm stuck in this catch-22 where I've got these printers and I need a printer to print parts for the printers to finish them. But all my printers aren't printing. So I can't print parts to make my printers print. You know the thing, like you can't find your glasses unless you have your glasses on. Actually happened to me the other day. You can't find a flashlight unless you have a flashlight first. You can't get a printer printing to print its own printer parts unless you have a printing printer. Well.
So wouldn't that be a good idea to get the printing get the chain at least?
Yeah.
Get the forge
just gotta
at least
get one
working?
going.
Yeah, just have at least one. Like that's it. You're not allowing my feet until you get one printer working. There you go. Forcement.
I don't know if that's possible.
We'll force you to get a printer working,
Mm-hmm.
But no, I was looking at like you said you wanted to go over a couple of the other information on the go, so let's go over it. You said there's some other changes you want me to do on the printer.
Yeah. So the motion system, right? Did you get you're going to have the jerk? You're going to double the XY acceleration?
Yep.
And you're going to increase that E maximum speed quite a bit?
Yeah, you said E we can go to for E we'll go to 100 max.
Mm-hmm. Also, just to avoid skip steps on X and Y, and this isn't crucial because your XY steppers are never going to hit this anyway because of step rate limits, but I would bring their maximum top speed of 500 down to 200.
Okay, so from 5 to 200. Okay.
That'll help.
All right. What about the what about just VVAX minimum being at 0?
That's good.
Okay.
All the rest can be left where it is.
Okay, nothing else has to be changed, eh?
Nope. Next thing I would do, let's look into those Bowden couplers, like they were saying earlier. Make sure those Bowden couplers are tight. They have good grip. The Bowden fittings are pushed in all the way. Everything is screwed in. Everything is tight. Nothing is slipping. You know, once all that is set, that'll be helpful. You might need to get new Bowden fittings. I don't know if those are the stock ones still. You might want to get some new ones.
They're stock.
Yeah, I've heard a lot of horror stories about the stock ones.
I am also going to be moving it over to Capricorn.
Oh, that's true, and that might help.
Yeah, I got some Capricorn kicking around here, so I'm going to be putting that on the printer. That's like another upgrade once I'm able to put on the V6 hot
Once you
end.
get that Capricorn on there, you might also be able to decrease the retraction distance a little bit.
Yeah. How do I tell what type of power supply I have?
What do you mean?
Well, I want to know if it's 12 or 24 volt. Or is it worth going to a 24 volt for your heater cart? Like, if I'm going to be getting some heater cartridges that are 24 volt.
Oh,
Is it
sure.
worth moving over to 24 volt?
Well, the thing is, I think the printer is 12. I don't know. You'll have to check. You can look at the power supply and tell. It'll usually tell you on it. If not, you can just take a multimeter, one on the negative, one on the positive, whatever it's telling you. It'll be either 12 range or 24 range.
Okay.
That's what it
So
is.
there's not like a one for 12 and one for 24.
Right. A power supply will either put out, like the power supplies that are in these things.
Oh, well, the CR12, the CR10 is 12 volt.
It is. Okay.
Yeah.
All right. Then yeah, all the positive terminals will be at the same potential relative to the negative or ground neutral, whatever terminals. So after that, well, if you want to switch to 24 volts things, you're going to have to switch everything. You're going to have to switch your bed. You're going to have to switch your heater cartridge. You're going to have to switch your heater fan. You're going to have to switch your cooling board fans. You're going to have to switch your like layer cooling fans. You're going to have to switch any LEDs you have on it. All the electronics are going to have to be switched. Some boards can't take 24. Some MKS boards can take either 12 or 24, which is a neat trick. But just depends. You know, you want to look into that. I would stick with 12 if I were you.
Yeah, I don't need to upgrade to 24.
Nope.
Okay. Makes sense.
The main reason people would switch to 24 is, well, okay, two main reasons. One, stepper drivers and stepper motors can work better there. But if yours are working fine, you know, don't fix what ain't broken. The other thing is bed power. Pushing more voltage means you can push more current with lower line losses on the way there. Yes, like John Mack says, if you need more power, you can skip 24 volts. You can go all the way up to mains voltage, get 124 volt, or sorry, 120 volt AC silicone mat. Slap that on the underside of like a nice cast aluminum plate. An SSR will control that nicely, and then man, you have power. That thing will heat up so fast.
Yeah, it's just because, I mean, I have the CR10. Yes, it has the heated bed. Yes, it has the insulation on it. It's just I am a very impatient person. I hate waiting 5 minutes for my bed to heat up.
Well, another thing I would do, and I do this on all my printers, grab some paper plates. Yeah, John Mack, yeah, the FT5. I see a lot of people doing that on the FT5, you know, that 1 foot square bed. It loses a lot of heat, and you put something like 500 watts or more on that, and boom, you can heat up fast. I saw somebody had a 1.2 kilowatt bed on there. Whew. That got hot.
Wait a minute, 1.2 kilowatt?
Yeah, 1,200 watts.
Is that what you guys are going to put on your printer?
Not quite that high, but no.
Come on, it's known as, you guys calling that the BAP. You should just go over the top with the BAP, you know?
Oh, we will, in some other ways. But
Hopefully, you guys can get that thing printing by Murph. That should be your deadline.
Oh, it'll be printing well in advance of then. Yeah.
Okay.
Yeah. We have to put that tech in another printer for a client, so
Oh,
we got to get it done so we can get paid.
how long have you guys been working on that?
6 months ish, 7 months.
I think you guys can put it together with less than a month.
We'll see. So what was I saying? Bed insulation. Oh yeah. So while it's heating up, you don't care if it's heating the air. It's actually better if you keep the heat in the bed, right? So what I would do is get sheets of something that doesn't like shed material, sheets of something slippery like foam board or something that won't stick to any adhesive you have on the bed, and just lay that on top, and that'll keep the heat down. So as it heats up, it isn't wasting all of its heat into the air. As a result, it reaches temp much faster, and once it does, then you can pull that sheet off. I use paper plates. Paper plates are easy. They don't stick to, like if you've got hairspray or something sticky on the bed, maybe have it really, really hot. Like glue stick can get kind of like goopy and sticky at high temps. These paper plates don't stick to it because they're cups, right? They just touch the shape, and I just lay a couple of them on the bed just to make sure it's all covered, and they'll keep the hot air in. And because you have lower convective losses, your bed will get up to temp faster. So just a little something you can do with the existing 12-volt bed, which can shorten it a little bit.
Makes sense.
Yep.
Yeah, so it's just like crazy idea to, heat up a bed that big. What else was I going to say? Oh yeah, we should talk about next time.
Yeah.
What should we cover next time as we go on in 3D printing? What's the next thing that gets you all pumped up about 3D printing?
Well, hopefully the next one will be this printer of mine here that I'm finishing up. So
when do you think you'll have that for
Core
display?
XYT should be done very soon.
Okay, so we don't have a time zone set for that one.
No,
yet.
sorry, not yet. I can't commit to that yet, but I'll try to get it done soon.
I'm only pushing him because I can.
Yep. Well, you're right too. I need a little kick in the pants sometimes. Otherwise, I tend to start a lot of projects and not finish them. Having people, remind me, "Hey, get this done," is helpful from time to time.
Hey, it happens to us all. I mean,
Yep.
Look at me with my print dryer. It took me how long to get that video done?
That's right.
I'm just a procrastinator. But yeah, no, the video's done, guys. I just got to put it together, and then I'm going to talk about a little bit more of the reasons why, it's so easy to build. It's only a couple steps, really. Daniel knows exactly what I mean when I mean by a couple steps.
Yeah. I know what you mean.
Yeah, it's been a busy day, guys.
Yeah.
Let's put it that way. We're going to call it here for the night. I want to thank everyone for tuning in, all the way from John Mack all the way to Trolling for Dollars for all his questions they was asking, dude. Hopefully we've answered all your questions you were looking for. Same with you, Chris Riley, Red Light, Apocalypse Survivor, and anyone else Zimmy also. And there's also, let's see here, Trolling for Dollars, Mescal jumped in. I told her this would probably be way over her head. Minnesota Maker, want to thank you for coming in here. Mm-hmm. And I think that's everybody. Oh, yeah, and then we also had Country Jump in the House, which was great. MAK 3D Designs. 3D Medic Vince, thank you for also jumping in. And 3D Printer Kid, since you were here too. Yeah, you. I just post me. No, we thank everyone for tuning in. So once again, guys, I want to thank you so much for hanging out, having conversation with us. It is late now for me. It's after 12, and Daniel wants to get home because he's been at the makerspace since God knows what time this morning.
Yeah.
So we want to thank you all for tuning in, and have yourselves a great night. And bye, everyone. Daniel, want to say bye, or?
Yeah, I suppose I will. Yeah, thanks for tuning in, everybody. I had a lot of fun. So.
Yep. Later, everyone.